Hi, welcome to a brand new SimplyMaya tutorial. In this tutorial we're going to cover the process of compositing. So we're going to look at getting out various different images from Maya. We're going to need a depth pass, an ambient occlusion pass, a volumetric fog pass. We're also going to need all the standard passes, a standard diffuse, a indirect lighting pass, basically everything we need. If I show you a render of this particular image here, everything we need to go from this to something a little more like this. So throughout the course of this tutorial there's been 4 previous volumes, whether we looked at texturing within Mari, we've looked at complicated paint effects, we've looked at animation on paint effects, and we've looked at modeling the actual house itself. So if you're coming with me from all those volumes, you'll have your own file. I've provided mine, so you can open that, and if we do a play blast of this scene, you can see that it's all animated. The trees are animated, the grass is animated, the paint effects, flowers and things here all have animation on them. Now if you haven't come from those previous 4 volumes, you'll find that this file doesn't have that animation on it. That's because this animation is reading from an Alembic cache, the pipeline cache, and I'm not uploading those files because they're around 5 gigs, so they're a little big. So if you want these animated, you'll have to open my trees and grass library, which I've provided, which has the raw paint effects on, and you'll need to generate the Alembic cache for these objects. Now if you're not sure how to do that, we cover the full process of that in volume 3, as well as the original animations and some of these more advanced paint effects techniques. So we're going to start off in this by compositing a still image. Before we get into compositing the animated image, which we'll need of course a background for that moves along with the image, we're going to just composite a still. So we're going to look at getting all those render passes out, compositing this still frame into something a bit like this. So we'll go from this, which is a little bright, overexposed, too green, no sky, to something a bit more like this, which is a little more atmospheric, a little more moody. And hopefully along the way you'll have enough information to just do this with any image. This is not about simply compositing this image, it's more about the information you need to get all the passes and whatnot out of Maya, all the mats, material IDs and things like that. So first thing first, we'll start with an ambient occlusion pass. Now right now our scene is pretty simple. If we look under the quality, we've got an overall quality of 0.5. We are using final gather with a setting of 50 and 0.2, 50 for the accuracy, 0.2 for the density, and just a couple of bounces. So it's a really simple scene to light. We're using a physical sun, but no physical sky. Under Maya 2016 you can just go in and create lights, and under lights we go for environment sky, and we went through the setup of all this in volume 3 as well, so it should be pretty familiar to you if you've come from the previous volumes. Anyway, I've kept it as simple as possible so we have fewer variables to deal with, and as I said, the first thing we're going to want is ambient occlusion pass. Now if we open up the render settings, you'll see here under passes, so under scene passes, you'll see that we've got an ambient occlusion we can tick. That's not going to work for us. The problem with that is it doesn't obey yet the visibility on the Mila material, and if you look at the leaves we've got here, they appear to be square, but if you look at the rendered leaves that we have, they are most definitely not square. So if we use that ambient occlusion pass, what will happen is that will render out square occlusions, which will never look right when we multiply that on the top of the diffuse pass. That's just going to give us a result that's not what we're looking for. Now there are ways and means around this. We could mask it with a material ID pass, but again that has its disadvantages. So I'm going to show you what you would get if you just ticked this pass box. Oops, the render settings, sorry. So if we just tick this pass box for ambient occlusion, I'll show you what we would get, and I'll do that with a render layer. So if we go down to the layers editor, and under render layers, basically I want to take all of this stuff except for the IVL and the sun. I don't need any lights. You don't need any light and information to render a ambient occlusion. It's all done pretty much on a surface shader. So let's just add this. So if you click here, that will add a new layer and include all selected objects. If you've missed one, you can always go back here, select it, and just right click and hit add selection, so don't panic if you've missed something. We click on this layer and we'll call this AO test. So now we've got an ambient occlusion test. If I go down to attributes and just under presets here, go occlusion, and what this will do, this will assign a surface shader to all the items in my scene. Now I've got use default material on, which has caused everything to disappear for some reason. So as you can see, if I go for the material attributes of any of this stuff, it's just applied a standard Maya surface shader, and to the out color it's applied an MIB ambient occlusion node with a very low sample count. So this won't be great quality occlusion, but you know, I'm going to show you some of the errors that pop up if we do this, and these would be similar errors if you just clicked here. So I'm going to show you why we don't. I'm going to take the image size down to 720 or 520. 540 will be fine for demonstration purposes. I'm going to pop open the render view, and I'm just going to hit render. Okay, so that rendered out, and it did a reasonably good job on the occlusion at the quality settings that it has. Now, one problem you might note is we've got the IBL still in the background, even though we didn't bring it into the layer. This is not really a huge issue though, because it is in the alpha channel, so we could always crop it out. But we shouldn't need to, so we can get rid of that for a start. The other main problem is that our leaves, as I said, have come out square, which is no good for us because these would actually be leaf shaped. So I'm going to lose all that detail that would be behind them. And our roof is flat. There's no displacement material been generated by this ambient occlusion pass, which is no good for us at all. Now we can fix all this. So let's go in, and I just want to give you a demonstration why we don't do it in the more standard way for a scene like this, which would be just, of course, to come up and tick ambient occlusion here, or just use a ambient occlusion layer with the standard settings. Now, you know why that won't work in this case. Now I'm going to empty this layer, so empty render layer, and then I'm going to delete it. Okay, don't need it anymore. We're going to make a new one for this. So there we go, got rid of that. Now let's make a new layer. Once again, let's take everything except the ambient, except the IBL and the sun direction. We don't need the light. And let's click for a new layer. So create new layer with selected objects. And let's call this AO this time, no test. Now we've got this, but we've got a problem. Now if we render it, it wouldn't of course be an ambient occlusion pass, it would just be a standard render. And we know we can't use the global material override because then we won't get any displacement and we won't get the visibility on these leaves to match the visibility that we have in here. Let me just pop open the render view once again. So let's have a look here, and you can see these leaves, as I've said before, they're definitely not square. And if we compare that, the reason why this doesn't look very good, by the way, is it's been double gamma corrected. If we compare that, you can see a lot of the roof behind here, and if we compare that with our ambient occlusion, all this roof is blocked off. So, you know, even if we masked this out in post-production and brought the leaves back to their original size, we'd still be missing a bunch of information from the behind them, if you like. So we can't do that. Now, let's have a look at what we can do. So we've got this AO here. And if we look at our materials, generally speaking, you would want to use a surface shader for this. It's always been the traditional workflow in the past, put a surface shader on, then hook up the transparency to the surface shader and have that render. However, as we've been using the Mila material exclusively in this tutorial, and the Mila material is a layered material, we can simply add a layer over the top, which will act like a surface shader. This will then already have all the displacement and all the visibility plugged into it. So if you go to your first Mila material and add a layer, and we want a weighted layer, and we want a emission. So we want an emission of 1, an emission intensity of 1, and in this case for ambient occlusion we want to put an ambient occlusion node in the color. So let's just go down to the mental ray materials, MIB ambient occlusion, and I'm going to leave that for now with its default settings. So you can see my material has gone white here. It's got this emission layer on the top with a weight of 1, meaning it will be the only thing visible, and intensity of 1. Now I can just, when I want to go back to the real render, I can just turn these off. I can create layer overrides for these as well. So let's create a layer override and tick that on. If I go back to the standard layer, master layer, and let's have a look again here. So let's try that layer override. Tick this off. Up here it's ticked on the AO layer, and it's ticked off on the master layer. So this means that when we render this out as an animation, it will render the master layer first with the base components, and then it will render the ambient occlusion layer with this emission layer turned on. So let's do another one. Let's do the second one in the chain, and it's the same thing. Weighted layer, emission, create layer override, tick it on, give it an intensity of 1, then go over to the textures tab, because we don't want to use a whole bunch of ambient occlusion nodes, and just drag that, middle mouse drag that into the color. Back to materials, here we go again, layer, weighted layer, emission, intensity of 1, color, we'll use the same ambient occlusion node. So all of these ambient occlusion nodes are now tied together, which also means that if you've got a big flat surface like the interior of here, where it's going to be a lot of occlusion, you can then put a higher quality occlusion node on. So you can mix and match as well. Now, higher quality means less grain, and if you're dealing with lots of tiny leaves, a little bit of grain isn't really going to be a problem. Over a large flat area, you might notice it more. So that means we could hook up a different ambient occlusion node into our emission layer for the house, and we get better quality occlusion on just one element without drastically increasing render time for everything else. So I'm now going to go through all of these Miele materials, which is pretty much all of these. I'm going to add that weighted emission layer. I'm going to make sure the intensity is 1. I'm going to make sure that the color is our ambient occlusion node. I'm going to create a layer override to turn that on, and that way when I go back to the master layer, I can turn that off because I don't want to render the ambient occlusion the master layer, and when I go back to the ambient occlusion it will be on. So after I've done all these, I'm just going to click through them again, looking for the master layer off. AO should be on. It's not, so I'll create a layer override. Must have forgotten on that one. And all you're wanting to see is off for the master layer, on for the ambient occlusion layer. So again, let's check this one. So let's create a layer override. I must have forgotten that on these. No, it does have a layer override, so I should just be able to tick it off and on off. Okay, this is off. We're on the master layer, and on. So we really just need to go and add an emission layer to all of these materials. So layer, weighted, emission, intensity 1, and textures for the color. Create a layer override, go to the master layer, remember to turn it off, back to the ambient occlusion, it's on. Okay, so that's perfect. That'll be active when we're on the AO layer and inactive on the master layer. So rather than watching you make me go through and do all these Miele materials, I'm just going to pause the video, and I will have that done when I come back. Okay, so I've gone ahead and done that to all of my Miele materials. So if we look now on the master layer, every material has this emission, and you'll notice that it's turned off. This is for the master layer, so we don't render out that occlusion. If we go to the ambient occlusion layer, you'll notice that the emission layer is turned on, and we did that with that render override. Now, it's only necessary to do this on the Miele materials, and the Miele materials are the only materials that are actually in use in the scene. We've got this surface shader here, which was left behind from when we made our original AO test layer. So as it's not necessary, I'll get rid of it. So that's really how you do it. That gives you an extra layer for the specific, an extra layer within the Mila material for the AO render layer here, and turned off. So let's get a render. So let's go to the AO layer, and I'm going to use use default material. Okay, so I've got this, and I'm going to render now. Problem is that if we look at the render view, this one had that IBL in the sky, which we have no need for. So I'm going to go over to the IBL, I'm going to go up to the attribute editor, and we don't need it to emit light, so I'm going to create a layer override, turn emit light off. We also don't want to see it. It doesn't make any difference because it will be part of the alpha channel, but you know, I don't like seeing it there, so I'm going to create a layer override and turn its primary visibility off. I'm then also going to go in to the render settings themselves. I'm going to go across to quality. Now I'll want to leave the overall quality the same, so the anti-aliasing matches, and I'm just going to come down to final gather, create a layer override and turn it off, because we don't need GI in a ambient occlusion pass, and this should serve to make everything a little faster. So I'll come up here, I'll just do a 1-to-1 on this, set the gamma back to the correct point, and I'll do a render now with our new AO. Okay, so that rendered out, and here we have vastly superior ambient occlusion for what we got before. As you can see, our leaves are the right shape, leaf shaped. Our displacement on the chimney stack and the roof is showing through, and if we were rendering at a bit higher resolution, you'd also be able to see a little bit of displacement on this path here. In fact, if I actually flick backwards and forwards, you can see big square, nasty leaves, no ambient occlusion, square leaves, to this one. It makes quite a bit of difference, especially as to what we can see behind here in the roof that would have been blocked in this one. Same with these trees, their leaves, because they're now the right shape when the occlusion is generated, you get a much nicer level of occlusion. Now, as I mentioned before, we're getting some grain, and it's difficult to see on this low-res image, but we're definitely getting a lot of grain, especially in areas like this. But if you look at the grass, the grain is not really going to be that noticeable. And the same with the leaves. I mean, they're so small that we don't really need to increase the quality on everything and thus massively increase the render time. We could just do with a little extra quality on the house itself. I mean, you can see it on this one, it's even more grainy over that large area. So let's come in and pop open the hypershade again. Give that a second and grab your house material. Now I've got mine here, main house, and this is of course linked with that emission layer on the AO render layer. So let's break the connection with our ambient occlusion and add a new ambient occlusion. Okay, now this one we can say maybe 64 samples, which will give us a much higher quality of occlusion just on that one material, which in this case is our main house. So let's just pop open another render, keep that one for comparison, and let's do another one. But this allows us to, you know, explicitly tailor where we need areas of higher quality and where we can get away with minimum quality, thus allowing us to speed up the rendering process. And this will get quite important later on when we come to render out the animation. Okay, so we managed to clear up the grain on the main house building itself. I'll do a flick backwards and forwards. You see very grainy, especially in here. We've managed to clear up all of that grain at a render time increase of 20 seconds. So if we'd have done that for everything in here, we'd have been looking at a render increase of maybe 10-15 minutes per frame, which, you know, is not necessary. Now, doing it this way, it gives us that extra degree of control to get the higher quality where we need it and the lower quality where it's acceptable. So that's it for this part. We've got our master layer and our ambient occlusion. When we come back, we'll look at depth and the depth of field, so a basic depth pass, so we can generate all sorts of effects in post with that, and then we'll also look at some volumetric light in fog just to give us a bit of atmosphere for our final image. So I'll be back in the next part. Thank you very much for watching. Hi, welcome back. Now we've got our ambient occlusion sorted out, we're going to create a couple more render layers here, one for depth and one for volumetric lighting. It's the same procedure. None of these need this lighting information. We will need some lighting information for the volumetric lighting, of course, because that will be shadow rays and sun rays, but I'm not going to use this. The reason for that is quite simple. This has ray trace shadows on it, and that will take forever to calculate a render. So I'm going to create a new light, match it to this one, and use depth map shadows. That's all that's necessary. So once select a new layer and add the selected objects with this button here, and we'll just call this one volume fog. So this gives us the volume fog layer. Now we're going to need to set up a couple of layer overrides. Once again, on the final gather, create layer override. We do not need this, and again with that IBL. So we don't need it to emit light. So create a layer override for that, and also for its visibility. Okay, so that way, again, with this render layer, there won't be any light coming from the sun direction. Now we are going to need a light in here. If we look under the sun direction, that's linked here to these ray trace shadows, and trying to create ray trace shadows through fog takes a very long time and makes very little difference to the final output. So it's better for us to use depth map shadows, but I don't really want to mess with the sun node, so I'm going to create another one. So I'm going to create and lights and directional light, because that's what the sun is. It's just a basic directional light. So we need to copy over the sun's values. Let's look at the sun direction, and this has a rotate, which is what we're interested in X. So let's give this the same rotate, and then up here copy the Y, and I'm just Control C and Control V for these copy and pastes, and copy, and finally copy. It's the rotation of a directional light that makes the light shine in that direction. Obviously, the translate and scale for these things is fairly irrelevant. If I just move this one up, just so we can get a look and scale it, you'll see it's in, if I go to the master layer, and we look at both of those, you'll see they're both pointed in exactly the same direction, which is the important thing with a directional light. The scale of it won't increase the intensity, neither will its position in space. It's really only the rotation that controls where the light's going with the directional light. So that's really all we need to match. Now I'm going to come in to our volume fog layer, and under the light we just created, so we'll call this fog light, so we know where we are. I'm going to create a layer override for illuminates by default. Now making sure I'm on the volume fog layer. Okay, I cannot create a layer override for that, so I'll just create one for the emit diffuse and emit specular. So create layer override, don't emit any diffuse, create layer override, don't emit specular. Now for this layer, for the fog layer, we'll want that turned on. For the AO layer, we'll want that turned off, and for the master layer, we'll want that turned off. Okay, so off for the master layer, off for the ambient occlusion layer, and that should be on now when I flick back onto the fog layer. Now the second thing is we've got ray trace shadows again. Turn them off. Turn on the depth map shadows. You might as well go for an 8K resolution. This is really quite fine for what we're doing. And fog shadow samples, I'm going to increase that to 40. Now at the moment this won't do anything except light up our scene. What we need for that is some fog. So we're going to use a volume primitive, create primitives, and let's just create a cube, and that will give us a volume primitive box. Now we're going to want to scale this box to cover most of the scene. The smaller this box is, the more intense the lighting effect will be. So if you were doing sort of sunshine through a window or something like that, you'd use a much smaller box, but I'm going for a kind of atmospheric fog. So I want to make sure that the whole scene here is covered. So you don't need to be too careful with this as it happens, but There we go, something like that. Make sure that you've got your floor plane covered here. There, that should do it. Now, if we open the Hypershade, creating that volume primitive should have created us a material, cube fog, which is created along with the volume primitive. So I'll shut down the Hypershade now we've got it. And we need to make a few tweaks. Now, the cube fog is what actually controls how this fog will look. So this shader is quite important to us. Now, I'm going to leave the fog color on white, just move it up there. Transparency, I'm going to leave to mid-range. Density, that's how dense your fog is. We're going to try this at a density of 1, and if it needs turning down, we can turn it down. Now, light scatter, I'm going to want that around 0.7. This will deal with how the light scatters through the fog. Drop off is how the fog will drop off when it approaches the edges of the cube here. So I'm really not going to do a lot with that because it's covering our whole scene. Now we want to take a look here so this material needs to be illuminated as well because we want illuminated fog. Now that should be about it for this material. This really isn't a complicated pass to generate. If we render this now, however, we're going to get pretty bad quality. Let's just give this a render and see what that's like. Okay, so that's rendered out, and that's definitely given us some fog that you can see. Now the problem with this is that although our materials are cut out in the right aspect, we don't want any of this information. I need these to be a flat matte black. So in the past we'd put a black surface shader on these, but again with the Mila material we can now come up into the Hypershade and add a new layer to them. So let's just clean that off, and this is the same procedure as we've done before. For the emission layer connected to the ambient occlusion, we'll now need another emission layer with a color of black and an intensity of 1. And this emission layer needs to now be added to every material with a material override. Now, I'm going to go ahead and add that to every one. So again, weighted layer, emission, intensity of 1, color of black, and a layer override. So in the past, instead of using one material to do all this, I would now have one main material with the textures and one material that was a surface shader with ambient occlusion on it and one material that was a black surface shader. This way, it's still a little time intensive, but at least you can do it now all within the same material, so you don't have hundreds of these knocking about in your Hypershade. You can still do this with a surface shader if it's your preference, but this way, for me, it makes a bit more sense. And a color of black. And once again, a layer override. So I'm going to get on with this and I'll be back in 2 seconds. Okay, so I've gone ahead and done that, given this emission layer an intensity of 1 and a color of black, but it does seem that when I added a new layer to this Mila material, it went ahead and forgot all of our old layer overrides. So what we actually want to see is both of these emission layers turned off in the master layer, the ambient occlusion one turned on the AO layer, and the volume fog one turned on the volume fog. Now what's been happening is if I go down to the master layer, you'll see that the AO emission is still on. So I turn that off, go to the ambient occlusion, and it's off. Go to the volume fog, and it's on. So it's forgotten the layer overrides we originally created. So I'm just going to have to come back in, make sure everything's off, on, off and on. So again, I'll just do one more because it's got a little confusing now. Master layer, everything should be off, which means there's no layer override here. Okay, so turn it off, come here, create a layer override, turn it on, and volume fog. So on the fog pass, off on the AO, off for everything. So I'll just come in, and here's one, master layer, both on, both off, up here, create layer override, turn the AO on, up here, create layer override, turn the emission on. All that's basically happened is as we added a new layer, it forgot all the overrides we had, which is a trifle annoying really. So let's just check this. Okay, this is the last one we're going to have to do. We will have a depth layer, but we won't have to add another material to it. We'll just be able to use this black material. So I'm just going along now and just making sure that all my ducks are in a row, so to speak. Making sure that the AO is on the AO and the fog is on the fog. Okay, so here's one that hasn't worked. Create layer override, done. And volume fog, ambient occlusion, nothing, good. The Mila material is still quite new within Maya, so it's got a little hiccup every now and again like this, like the fact that it forgot its layer overrides when a new layer is added to it, which is a little annoying, but I'm sure it will get better as time goes by. It also does a couple of tricks, like when you delete a layer, it's still hanging about in the hypershade. You have to go in and manually delete it. And there's a couple of small niggles with it as of yet. It's still an excellent material, the best one Mental Ray has ever had, in my opinion. So I kind of forgive it its little quirks. Okay, and we're just about finished now. Just recreating those original ambient occlusion layer overrides. Couple more. Okay, and it's really definitely a step we could have done without, but you have to be on a layer to create a layer override, by the way. You can't create one from the master layer. You'll just get a lock attribute, just in case you're sitting on there trying to figure out where it's gone. So we have a layer override done. Okay, that was the last one. Alright, so now let's do another fog render. So I'll go onto the volume fog channel, render layer, and hit render, and we'll see what we get this time. Hopefully something a little more fog-like than what we've got there. Okay, so now we have everything in grey, which is a start, but this is a terrible quality of fog we've got here. So let's sort that out. Let's select the fog box that we've got. Just make sure it's in the right position, and I'm going to move this closer to the camera. The middle of the box is where we'll get the most fog. So for a start, we don't need to be generating a massive amount of fog at the back. We want it kind of focused where the camera is looking at. So around here should do it. Make sure we've got all those trees enclosed. Now that will just change the point of most fog, which is good for us, but also we don't really have a lot of volume samples. So if we look at the volume box shape, and under, where are we? We are looking for render stats, and we want volume samples override. We also want some depth jitter. So let's give this to start with a fairly low sampling of 30 samples and see if we get much better quality with that. We definitely should. So let's come down, let's kidnap this old render, and let's do a new one. So that finished, and we have a much better quality of atmospheric fog. You can start to see some light rays coming through here, and if we compare that to what we had before, you'll see quite how important that volume samples is. Now, depending on how accurate you want this fog pass, you can increase the volume samples. In our case, they added 20 seconds to add 30, but that will be in a logarithmic scale. So if we add 60, it'll take probably a bit longer, and I'll get one of those in a minute. I just want to show you what happens if we reposition this fog box. So right now we've got sort of general, what I would call atmospheric fog, that can be screened or plussed over the top of our image to give us a kind of atmosphere to it, a little haze, but not really those big light streak God rays that you get. Now, we don't really have a scene for that. In order to get those kind of humongous streaks, you need light coming sort of directly from behind this tree, or we would, and very bright points of light, and that's not really what I want to achieve here. But if you want to make this effect more dramatic, we can do that by making the scale of the box smaller. Now, we could just make this box smaller, and if we make it bigger, we're going to get a less dramatic fog. So come in here and move this towards the center of this tree, really where the camera is. Now, I said make it smaller, and you'll notice I've made it bigger. This is because I'm going to have a background fog, and I'm going to come now and create another volume primitive. So I'm going to create let's see, a cube again. And this one I'm going to make much smaller. Whoops, let me just pull that forward. And I'm going to get it right over this tree here. So I'm going to get it center of that tree, and I'm going to literally make it about yay big. Probably doesn't need to be all the way up there. Done. Now this will share the same cube fog shader as we already have, so we're already set up. So all we need to do is drop this in here, go under its box shape, turn on the volume sample override, and I'm going to use 30 samples again, and when I re-render this we'll have a patch of much stronger fog at the front of the camera. Now for the effect we're going for, I don't think it's necessary, but I want to show you what happens. So save this one, and I'll be back in a second after this is rendered out. So adding the extra fog box has given us a much more intense fog at the front here, but we're still seeing that fade out towards the back trees. So we get kind of this fade left where it should be, and a much more intense scattering of light at the front. Now if I was going to do this, this is probably a bit too intense. So if I was going to use this technique, I'd probably go to the cube fog and crank down the density to maybe 0.5 or maybe less. Now it entirely depends on what you're going for. Me, I'm going for just a little bit of atmospheric fog. You might be going for light shining through a window or something like that, something much more dramatic. I will get one last render of this with both fog boxes and the density at 0.5, and then we'll move on to the depth, which we'll do in the next part. Now you'll be happy to know we don't need to create any more Mila layers for that. The depth pass can be generated using the same layer, that black with an intensity of 1, that the fog pass was created with. So I will be back when this render finishes, and then we'll move on to the next part. Okay, so that rendered out with kind of a lot less density. So it's really just a question of what you're looking for. As I said, you can always alter them in post to get more of what you're looking for. So I don't tend to spend too long on these. You know, just get the basic effect. And for me, it was probably the first one. So I hope you found something that was useful in this part. And before I sign off, I just want to go to the other channels. So the master layer. Select both the fog boxes and Control H to hide them. The ambient occlusion layer, they're hidden, and the volume fog, Shift H to show them. And you'll notice that they're hidden now, grayed out, in the master layer and the ambient occlusion layer. When it comes to the volume fog, they light up. So that way they won't interfere with any of other of our render layers. Okay, and I'm going to do the same thing with that fog light as well while we're here. So master layer, hide it. Ambient occlusion layer, hidden, volume fog, Shift H, show it. Just keeps all our layers nice and even, and makes sure that when we hit a batch render and it renders out all of these layers, that it's not going to come and do something like try and introduce a fog pass to our master layer with these boxes. So that's all of our ducks in a row, so to speak, and I'll be back in the next part when we'll look at depth and material ID passes. So thank you again for watching, and goodbye. Okay, welcome back. So in the last pass we finished off our volume fog, and I've taken the liberty of just rendering out all three passes here. So this is our master beauty, our master layer, this is our ambient occlusion, and this is our fog. So it's not a bad idea to do a test render of these at low resolution, just to make sure all your material overrides are actually working. Nothing worse than rendering out a couple of hundred frames only to find that you've missed a material override and now we've got some kind of bright green trees in the fog pass, or the fog pass overlay in the beauty or whatnot. Now the other thing I wanted to show you was this is rendered here without the environment light on. So this is 6 minutes and 49 seconds to render, and this one is with the environment light, and it's double the render time almost. You can see the environment light definitely adds to our overall GI, but that does come at the cost of a significant increase in render time. So for a still shot, I'd probably use the environment light. For animation, I'd probably turn it off and go with a post solution to kind of beef up that GI. But we'll be dealing with both the still and the animation. So I just thought I'd render it out so you could see it, so you don't have to. So we've got our three passes, and now I want to talk about depth. So we need a depth pass, and if we look under the Maya render passes here, you will see that there is a depth available to us along with a whole bunch of other stuff which we'll be getting into in a second. Now a true depth pass doesn't contain anti-aliasing. It's simply a representation of each pixel's distance from the screen. So if you anti-alias that, what you're going to get is a situation where, if I can actually zoom in on a render here, I should be able to show you. So we'll take this ambient occlusion for instance. So you can see the edge pixels here of the anti-aliased, which means they're a different color than the main pixels. So on a depth pass, that's not always desirable. If you were doing a quick comp in Photoshop, I would generally use a anti-aliased depth pass. If I was doing a full composite, I would generally use a non-anti-aliased true Z-depth. So I'm going to show you a technique for making both, and you can use whichever one fits the situation. I'll demonstrate the use of both, but there are, a number of schools of thought on depth maps, and some people swear by an anti-aliased one, and some people a non-anti-aliased one. For me, it depends entirely on the situation, so I'm just going to go ahead and create both. So to create an anti-aliased depth map, we're going to add a new render layer here, and we're going to select all the things we need in that. So that would be basically everything once again except for the IBL here and the sun direction. So we don't need to fog light any of the fog boxes, we need everything else. So I'm just going to create new layer, and I'm going to call this AA depth, anti-aliased depth. Okay, now as we've done previously, we need to set some layer overrides for the render settings. So let's come into the render settings, and first things first, let's set a layer override for this. Let's turn that off. Let's go to the IBL and set some layer overrides for that. Okay, so we want to create a layer override for this emit light. Even though it's off, we may turn it back on again in the master layer. So we want to make sure that it doesn't go on in this layer. So if we come up here and turn this on in the master layer, we want to make sure that that's off in the depth layer, and it is. So just, if you decide to use that environment light, we don't want that going on for all the channels as well. So let's see what else we need to set. We've turned off the final gather, we've turned off the emit light of the IBL, and we'll also turn off the primary visibility because we don't need to see that in a depth pass. Okay, so that's basically most of the overrides we need. Now we need to talk about materials. As before, we created a material for the ambient occlusion and we created a material for the volume fog. Well, you'll be happy to know that we can use the same material for this anti-alias depth here. So let's go and make sure our materials are turning on in the right order. Okay, so here we are. For now, volume fog uses this material, ambient occlusion uses this layer of this material. We need to get this to use this one too. So let's just check that. Same one for volume fog, turn off for ambient occlusion, and Okay, we're going to need to create layer override, off. Okay, so that's the setup you want to see. Both of these off for the master layer, this one on for the ambient occlusion, this one on for the volume fog, this one on for the depth. So again, this should be quite simple. Create layer override, we want that one for the fog. We want that one still for the AO, we want that one, and for the master layer all off. So I'm just going to run through and check my materials here, and I'll be back in 1 second. Okay, so that's done that. Just basically click create layer override and tick the box, and that's all you should need to do. Double check everything afterwards, because like I say, there's nothing quite worse than doing a very long render only to find out you've got some fog in the wrong place, or one of your materials is bright white or black in the wrong particular layer. So that's done that. So basically volume fog and anti-alias depth use the same layer emission, basically black with an intensity of 1. So now we've done that, we need something for it to render, because at the moment everything is just going to render black. Now for the volume fog, we used a volume fog box. For this, or we used a volume primitive in the shape of these boxes here. For this anti-alias depth, I'm going to use environment fog, but you won't find that under Mental Ray. You have to go to Maya software. Now we'll be rendering in Mental Ray. We're just going to tick open the option here in Maya software. So if I go to, where are we, render options, and I see environment fog, as soon as I hit this box, it will make an environment fog shape. Now if I go back to Mental Ray, you'll see the environmental fog shape is still there. So that's all we need to do to expose that particular node. Now I can click on this environment fog, and under its render stats it will have a volume override. So let's give this 30 to start with. The higher this goes, the longer your render, remember. So you want to use what you can get away with. Now I'll probably go higher than this. I've been known to go up into the 150 to 200 range, but for testing this should be fine. So again, and it's the same settings we used for the volume primitives, so same principle really. Now you've got the fog light control, and at the moment its shadows will be used ray trace. We don't need that. Now this will give us a better quality render, slightly better edge anti-aliasing, or slightly better edges, but it will take 3 or 4 times as long. So for now we're going to leave this off and hope we don't need that extra boost in quality, because we don't want to spend the time rendering it, of course. So most of the settings, as with the volume primitives, are under the material. So if we look in the hypershade, when we created this environment fog, we should have also created this fog material. Now saturation distance for us is kind of crucial. This is the distance that the fog will be saturated at. Now we don't know that at the moment, so let's find out. And to do that, I'm going to measure this scene. So I want anything forward to the camera to have a low value, so black basically, and anything at the back of the camera to be fully saturated, so white. So I'm going to grab a measuring tool, create measuring tools, distance tools, and I'm going to set it here at the front point of the camera, and then back here maybe to where this ends, and we get a distance of about 330 Maya units. So that should be fine for us. Now we need to go back into that fog shader. There we go, environment fog, and saturation distance, we'll call it 350. So I'm not going to do anything too fancy to this. The color is fine, being white. Physical fog is not necessary. Clipping planes we'll need to use. So I'm going to set a fog near distance of, say, 10 units away from the camera will be the nearest distance, and the fog far distance 350. And then we'll need to do a couple of test renders just to make sure that's okay. And you know what we're looking for in a depth pass is the front to be black and the back to be white. So let's get a camera view of this, and that should be it. That should be all that's required to create an anti-alias depth pass. So let's hit render and give that a go. I'll be back in a moment. Okay, so that rendered out, and here we have one anti-alias depth pass. Now this is useful for quick comps in Photoshop with Photoshop's lens blur. If you feed this into the alpha channel of your image, this will blur quite nicely in Photoshop. But if we look at it, you can see all these pixels slightly different colors, especially around the edges. Now this is supposed to be a perfect representation of the depth, with black being closer to the camera. So at the moment it thinks that this black is closer than this, which obviously it's not, because this is one leaf and it would all be the same distance away. So, you know, a true Z depth should contain no anti-aliasing. The problem with that is that if you use no anti-aliasing, like with a true Z depth, then quick comps without splitting the images into all of its component parts become very difficult, because you'll see horrible edges on your blur in things like Photoshop. So that's the reason I generate both, and we will use both and you'll be able to see the difference. Now for me this is pretty good. Darks right at the front here. These leaves are obviously poking out from the tree, they're darker than the trunk, and at the back we almost got pure white. However, the transition is a bit harsh, and we can solve that by just increasing the quality here on this volume sample. So I'll put that up to around 60. Might need to go a bit higher, but I think that should do it for now. Now let's just have a look. Let's make sure before we do anything else that this volume, this environment fog at the moment, it was going to render over every single render layer that we have, which is not ideal. So I'm going to hide it. It's hidden, it's hidden, it's Control H to hide and Shift H to show. So now it should only be visible and only render in the anti-alias depth, which indeed it does. So there's one depth pass. Now to get a true Z depth, a non-anti-aliased one, we need to go up here and start to use these render passes. Now this is where you get your direct diffuse, your indirect light. So this is where we really start to split the master beauty up into separate passes. And you can split this into a collection with the new passes system. So you can get a direct diffuse, an indirect diffuse, a direct glossy and specular, or you can break those apart into a direct glossy and a direct specular. So depending on the scene that you're compositing, you might need to break apart just into these layers or all of these layers. Now, as I'm going to keep this simple, I'm going to break this apart into the direct diffuse, the indirect diffuse. This is direct lighting and the indirect lighting contribution, and this is all the glossy and specular highlights for the direct lighting, and this is the glossy and specular highlights for the indirect lighting. I'm going to break this into refraction. And front and back scatter, if you're using subsurface scattering materials, you'll need this. If you're using materials that have emission, you'll need the emission. I'm not using any subsurface scattering in this, and although we have emission, we only have it on these layers, and we're not going to want passes for these layers. For instance, I mean, we don't need a direct and indirect diffuse for the volume fog, we just need the volume fog. So we're going to have to set up overrides for these in a second, but let's just get what we need. So this will break up the image into all these separate images that we can then recomposite back together. This gives us much more control over the process, and you know, control is something we like. So here you could split the direct and glossy passes, the specular and glossy passes. We are not. You can also split direct light passes. So if you have 3 or 4 lights, at the moment this only supports 4 lights. If you had 4 lights in the scene, what this will do is render out the contribution from those lights separately. Now there's a tutorial on SimplyMaya about that that's done in a much more complicated way. It's a very advantageous thing to do. Let's say we were rendering this scene at night and we had a porch light in here and maybe some lights on in the house and an exterior street light, some light from the sun. This would allow me, split the light passes, would allow me direct control over the illumination of each light. So in the post-production process I would be able to then turn the porch light down, turn the house lights down. This gives you a fantastic degree of control. The older way to do it was with pass contribution, the pass contribution maps and various other complicated ways to achieve this. And like I say, there is a tutorial on the site, but this new workflow is much simpler. But because we're only actually using one light, it's of no good to us. But bear it in mind, set up a scene with a couple of lights, hit this, and then have a look in something like Nuke at the passes that come out, and the advantages should be fairly obvious. Now we have this Mila map passes, and this will create a mask for every single material that we have. So say these leaves, for instance, this will create a mask for these leaves, which means when I get it into post I can mask them out, color correct just these leaves. It will create a mask for the roof, for the house, for the grass, for the floor. For every material we've got, it will create a mask. So I'm definitely going to use these map passes. Now you can create your map pass set if you want to. So we're going to click our own set, and we've got our own set here. Now what this allows me to do is mix and match these. Normally it's not something I'm going to show materials I bother with too much, because I can mix and match the various masks in post. But let's say I wanted the main house and the roof. This would now be one matte set. So this would give me a matte of both of these objects together, or in this case both of these materials together. Really I'm going to show you how to make your own sets in post anyway, so this is kind of a quick way. At the moment, with the Mila material being so new and this pass system being so new, this doesn't always work for me for some reason. Even if we go up to here and tick off display DAC objects only, and then just hit star, pass, star, this will search for anything with passes. So you can see all the various passes here, and I've got a matte set 1. And if we look at its attributes, it's not set to renderable. So, you know, that wouldn't have worked. And if we edit the map pass set, you can see here material set 1. So set 2 is also created. I must have created it at some point in this file, otherwise it wouldn't be there. But we're just going to set that matte set to renderable. And then it should render out. Like I say, I've had trouble with these matte sets. Hopefully that will be fixed in an updated version of Maya, and again it's always possible to create your own matte sets afterwards. So, and by the way, doing this lets you select all of these passes, so you know, just a thing if you need to tweak something. If something's not rendering out, for instance, like you wanted your direct glossy pass, you can see here that it's set to render from here. But sometimes this can get turned off, so you know, it's a brand new system, so there's bound to be a few bugbears in it. So if you do render out and you're missing a pass, you can always come up here, untick this, search for passes, just make sure they've been set to renderable. Now we have certain utility passes, so we're going to want a depth, which will give us that unanti-alias depth. Now with a normal and a position, you can relight the scene in Nuke. Again, not something I'm going to go over, but very handy passes nonetheless. With a UV pass, a normal and position, you can even retexture in post. So, you know, bear in mind, good passes to have increased render time. So for us, not necessary. All we actually want out of the utilities is depth. Okay, so that will give us all of those passes. Now, if you're having trouble with your anti-aliasing, you can hit contrast all buffers here, and this will clean up, do an oversampling basically on all the color buffers. So if you have problems with anti-aliasing between intersecting geometries, you may need to tick this. Again, increases render time, so I wouldn't recommend it unless you're having a specific problem. So there we go. So that's our passes. Basically, we're going to split the image into its various components. We're going to create a map set of map passes, and we're going to create a depth. Now, this is fine for the master layer. Obviously, these are all the things we want. But if we flick over to AO, you can still see these are still here. So we need to create layer overrides, because we do not want these all rendered out for every layer. Okay, so let's just make sure we've got them all. Okay, it's going to error because it can't find some things because I've turned them off, but that should be fine. Let's just flick down to the master layer and make sure everything is on. It is. And let's flick over to AO, make sure everything is off. It is. So just do that with the other layers. And up for a quick check. Okay, done. So everything on. Yes, everything off. Yes, everything off. Yes. And final one. You might notice I do some extra checks which might seem a bit paranoid, but when you're rendering out at 4K and your render's going to take more than a few hours, it wouldn't be the first time that I've come back to it and accidentally left a whole bunch of unnecessary passes on, which can really ruin your day in terms of render time. So a quick check is really not a luxury in this case. Okay, so before we go any further, if you've never worked with render layers, render passes, and you have no idea why we'd break all this down, I'm going to want to create some additional mats in Maya and some other stuff. But first I'd like to get a render out, take it into Nuke, and just show you what all these things are actually doing for us. If you've done some compositing before, you'll probably get what we're going with this, but for those of you that are perhaps new to this, I'm just going to show you how to put these layers back together, and obviously we'll do that for the main composite. And more importantly, I'm going to show you what these layers actually look like so you can get a better understanding of what it is that we're doing here. So I'm going to close that render settings box down. Now here, these are not renderable at the moment. There's a really small X mark on there in yellow. So I'm going to tick them all, and that will allow me to render them all. So for this I'm going to need a batch render, so it renders out all passes, all layers. So render out all the passes on the master layer, and then it will render out all these separate layers. I'm going to go up to my settings under common. I'm going to make sure that, let's see here, I'm only rendering out one frame. So at the moment I'm on single image, so that's fine. Let's go name, number, extension, and I'll be on a frame range, so 1 to 1. Simply because I don't want to render out the animation yet. Part of this, and part of the reason we're going to go and check all this, is so we don't end up with 125 useless frames because of a simple mistake. Now I'm going to use OpenEXR. Now this will allow me to store all the render passes in one file. So if you're using something like TIFF, what will happen is Maya will generate one image for the depth, one image for the transmission, one image for the specular, one image for the direct specular, one image and one image and one image and one image. So you can end up with hundreds of images, for relatively few frames. So I prefer to work with EXR. It's Nuke's preferred format. It's probably also the most common one used now in the industry. It contains all the data within it in a nice package that we can then separate out. So I'm going to use image compression on the EXR. You don't have to, but you will generate much smaller files. So let's see, HD 540 will be fine for a test. Quality I've got set at 0.25 just for this test, and legacy options we've got the final gathering set to a very low accuracy just for the test. Okay, we're using 16-bit frame buffers. Now you'll note that if we search for that depth pass, so let's go DAC objects only, pass, and we should see a depth here somewhere, depth pass. You'll see that this is set to 32-bit, so you can set the buffer type within the passes themselves, but for the majority 16-bit float is absolutely fine. Just make sure you don't go down to 8-bit, otherwise you're going to run into some serious problems. And for the data type for the passes themselves, we've got RGB half 3 times 16-bit, because this one is red, green and blue, hence the 3 times 16-bit, and this one is red, green, blue, alpha. So the passes won't come with an alpha channel. We don't need that for a simple composite like this. Okay, that's all done. Now I'm just going to hit, just make sure we're all turned on here. Now I'm just going to hit render, batch render. And that will go ahead and render out each pass for the master layer. It will then render out the ambient occlusion as a separate image, the volume fog as a separate image, and the AA depth as a separate image. So that's pretty much it from me for this part. I'll see you in the next part. We'll be opening this file in Nuke and getting our first look at all those passes. So thank you very much for watching, and I hope you found some of this useful. Cheers. Okay, so we're here in Nuke and we've got our test image rendered out, so I'm going to load that in, and mine has gone into the images tutorial directory. Yours will probably be in your project folder just under images. Now as you can see, each render layer that we did has got its own directory, so the volume fog will have its own EXR, the master layer, the ambient occlusion and the anti-alias depth. But you'll notice all the other passes we put in, the diffuse, reflection and all the matte passes, aren't there. That's because they're contained within the master layer file itself. So this single EXR will contain all the information we need for those passes. So if I drop that into Nuke, and you can get a read node in Nuke by going up here or just pressing R. Now if you're new to Nuke, it's a node-based workflow, so each element will be its own node, and you simply connect those nodes together by dragging these arrows. So for instance, to connect that to the viewer, I just drag upwards and there we go. Right, so here is our image as rendered out of Maya, and this would be the beauty. Now in order for us to do anything with this, we need to break it up into its component parts. Now one of the reasons we do a very small test render is to make sure we actually can recombine all the elements back into something that looks pretty much identical to this, because if we can't, there's something missing. Now I also brought you in here, if you've never done this sort of workflow before, I just wanted to show you the result of all those passes. So let's have a flick through and see what this file actually contains. Now if you go up to this part of the viewer where it says RGB alpha, we can flick that down and this will show us all the independent images that this file contains. So for instance, we've got an alpha channel and we've got a depth channel. That would be the depth that we did in the past system, of course. Now this looks just bright red, and you'll notice there's no anti-aliasing on this one, or very jagged edges. Now don't panic, this is actually a proper depth channel. If you look down at the bottom of the screen where the red numbers are moving, sort of in the middle of the screen under my mouse pointer here, you'll see at the front of the camera they're reading a value of 22, and as I move backwards that value goes up. Well, this is actually the depth, so if we get right to the back of the image, we should be around 300 units away from the camera, and we are. So we can say we've got a fairly successful depth pass here. If I go back here to this tree, it's about 260 units away from the camera, and of course right in front of the camera we got about 20 units. So we're fine for the depth pass, that worked. Now as we go down, we've got a direct diffuse. This is the contribution of just the direct diffuse lighting. So this would what we would see if we took all the GI out of the scene. So basically you can see we've got very strong shadowing here and no bounce light at all. Now we also have a direct glossy and specular. Now this is a combined specular and gloss together. As we mentioned before, you can actually get these out as separate passes. And we'll look at doing some light path expressions to get more complex passes out in a second. We've got indirect diffuse, which is the contribution of the GI. It's the light bounces basically. So this coupled with the other passes together will go back to make up this. Now as we keep going, we've got the indirect glossy and specular layer. And we've got the indirect glossy specular transmission, which will probably be empty. It is. we have no indirect specular transmission in this image, so we're not getting anything in the pass. Now we've got all the mats as well. Every Miele material we've made a mat for, so you can use this one to mask out the daisies. You could use this one to mask out front door area. We've got one for the guttering, one for the grass, one for the leaves, for instance. So we can use these to really mask out our trees and kind of work on them independently. Now I'll give you an example. Here's the mat set we created, which was the house and the roof combined together. So let's see how we would utilize one of these. Now at the moment they're all stuck in this one file. So to get them out we need a shuffle node, and within Nuke if you just hit the tab it will bring up a list of nodes that you can then just type in the first few letters of, and you'll see shuffle here, or you can use the menu, the shuffle there. So you can access all the nodes this way. Or as I say, you can just use that tab key and type in what you're looking for. So once you get used to using Nuke and you get a bit more familiar with all the nodes in it, tab is probably the easiest way. And you should be used to that if you're used to Maya's node editor. It works in the same way, so it's nice you keep the same similar workflow. Right, so we've got this shuffle node now, and I want to break this image out of the main EXR. So I'm going to connect this shuffle node up to here. I'm going to tell it that the in is that mat set, so mat set 1, which is this, and the out is RGB. So if we set the viewer back to RGB alpha, we can now use this to mask the main body of the house when we add something, a color correct, a hue shift, or something like this. So let me go click this node, hit the tab, and I'll add some sort of hue shift. So we can change the color of this image. Now if I just change the overall saturation down to a black and white, this is going to affect the whole image. Now if I pull this mask out here and attempt to connect it to this, that's not going to make it very happy. And let's just try that again. There we go. Connect that to that. And you see that this didn't really work. The whole image is still black and white. Now this is because we are using a black and white image and we're outputting R, G and B, and we don't need to. We're just going to output R. We just need one channel for black and white. Then we're going to go into the hue shift, and the mask is not RGB alpha, it's the red channel. And there we go. The house is black and white and everything else is in color. So now we have control enough that we can take this house and let's say recolor it. So I'm going to make the saturation more, so we have a very saturated house. I could now do a saturation along axis to subtly change the color. I can do a brightness. You know, I've got control through that mask from the house. I mean, if you're at all familiar with masking in Photoshop, you'll know exactly what sort of flexibility this gives you. And we have a mask for every material we have. So it gives us a great deal of flexibility, along with the depth and the ambient occlusion and everything else we've rendered out. This will give us many possibilities for the composite. Alright, so let's just detach this shuffle node altogether, and let's get rid of this hue shift. Now you can just hit delete to get rid of those, reconnect this to the camera, and now we have to see if our passes, our direct, diffuse, our indirect and whatnot add up to make this master beauty, because if they don't, as I said before, something is gone very wrong. Now, and again, one of the reasons why we do a smaller image is often something gets overlooked and you really don't want to render out a whole animation only to find out you're missing something from your master beauty. So right now we have, let's see how many things. We have the direct diffuse to get out, the glossy and specular, the indirect diffuse and the indirect glossy and specular, and we know there's nothing in this indirect specular transmission, so we don't need that. So we're going to need 4 shuffle nodes to shuffle that lot out. So let's just hit it. Let's shuffle, and 1, 2, 3 and 4, and I'm just pressing tab, brings up the last thing you inputted, and then enter to create another one of those. So we got 4 of those. Unhook them from each other. They come in hooked up together, which we don't need, and now connect them all to the main image. So I'm just going to shrink this image up here a bit. I'm going to move the main viewer. Workflows in Nuke can get a bit messy with nodes all over the place, so it's best to try and keep it a little organized. And I'm going to start by shuffling out the direct diffuse. Now again, we want RGB, and I'll give this a name, DD, direct diffuse. Next will come the indirect diffuse, RGBA. So indirect diffuse. Then we'll have, so basically the direct lighting contribution, the indirect lighting contribution, and then we'll need the glossy. So the direct glossy specular, RGBA. I'll just call this gloss. We'll know that it's gloss and spec, but that's fine. I've only got so much room in these boxes here. And let's then the indirect glossy and specular. Indirect gloss. Okay, so now we've got these passes out, and if I click and hit 1, they'll go to the viewer. So we can just, I normally work on Nuke on more than one monitor. So if you've got one, you can hit float plane and shove the whole viewer on another monitor. It makes the whole process a bit easier. So there we have the direct diffuse, the indirect diffuse, the direct gloss and specular highlight, the indirect gloss and specular highlight. Now we need some way of sticking these all together. And in Photoshop you just layer them. In Nuke you have to merge them. So we've got 4 elements here. So I'm going to need 4 merge nodes. Now I just hit M, which is the shortcut for merge. So, or you can find it here, of course. Merge. And they've come in connected together again. So let's disconnect them. And this is going to be A over B. So we want A going up and B going over. So this will go over this. So if we were layering now, this would be the top layer. And then this one, and then this one, and this one has nothing to connect to. So before we get into compositing for the background, because at the moment we just want to see if this combines back into the master beauty, we'll add a constant node. And before we do that, we're going to need to look at our project settings within Nuke. Now I'm going to clean up this because this has got a record of all the nodes I've used so far. So just hit here and that will clean up the properties box. Click anywhere in this window and hit S, and that will bring you to the project settings. And then we need a size format. Now I'm using a 960 by 540 image, and I've got a tick box for it here. If you haven't, you'll have to go New, create a file size, width and height, and give it a name. So let's just set our project to the right size. There we go. And now I'm going to use a constant, which is just a constant background basically. So I can now connect B up to here, and that will give me a constant background, which means that when I finally look at all this, I'll connect it to the viewer, you'll see, realistically speaking, what I'm getting here is just this. And if you look at our merge nodes, and I'll go into what this is for in a second, if you look at our merge nodes, they're all set to an over operation. So this one is over this one over this one, and this one over this one. So we're never going to get anywhere like this because this image is entirely covering up this one. So let's double click the merge box, set the operations plus, then do the same with the next one. Plus, this is a bit like the screen in Photoshop. Plus, and speaking generally, we want to use plus operations in pretty much all of our compositing, except this last node. We don't want to plus the direct diffuse with this constant here. And you'll notice the background is black, whereas the background of this one is blue. That's because if we take a look at the alpha channel, and we'll have to take a look at the alpha for the main image, you'll see that the background's not included in the image. It's not a problem for us. We never want it included in the image. You want to really add your own background, which is temporarily what this constant is for. So let's look at the last merge in the chain, and let's put this viewer to RGB. Okay, and that's not showing me anything because it's set to alpha. There we go. So this should be exactly the same now as this, apart from the background. And that's why I put this constant in there. And if you want to organize this a bit better, you can actually hold Control, and this will bring up the menu that lets you kind of tweak these, so you can get a better flow on your node chain. So here we go. Now I'm going to put a kind of blue color in this constant, so we have similar blue to here. So I'm just going to hit the color. Let's get a bit of blue in there, and pretty light blue. That's pretty horrible. There we go. Sort of a light blue. We don't have to worry about it too much. And let's check that this, apart from the sky of course, resembles our master beauty. So I'll pull in a little bit, and I'll just flick backwards and forwards between them. And in fact there's an easier way. Rather than flicking backwards and forwards, I can create a new viewer. There we go. So I've got viewer 2. I can split this plane on the horizontal, and I can tell this one that it's viewer 2. So I'll just drag this viewer up and dock it there. There we go. So let's get this image to a right size, and you can see why I normally work on 2 monitors with this. And let's drag viewer 2 up to the original image. Okay, now if I do a side-by-side comparison, you can see this tree is not the same as this. I mean, the house is exactly the same. At least it looks exactly the same. Let's have a look. Yeah, the house is exactly the same. Okay, let's see what else is different. The grass here is definitely greener and brighter, I would say, and the tree leaves are definitely different. So we've obviously got a pass missing. We've got some information that is in this image that is not in this image. Now we need to identify what that is and find out why it's missing. So if I jump back to Maya and we take a look at some of the materials we've got in this scene. So I'll just do a material attributes here and leaf type A. You'll notice that I am using a diffuse transmission with these. Basically it's a, if you haven't seen the other parts of the tutorial, it's a translucency. So we seem to be missing that, would be my guess. And the reason I've gone there is because our house is not affected by this, only our translucent objects. And indeed, if we look at our render passes here, we've got a direct diffuse, an indirect diffuse, a direct glossy and specular, an indirect glossy and specular, and we've got an indirect glossy specular transmission, which, if we look at it, doesn't contain any information. So we can just set this on the viewer here and have a look. Direct glossy specular transmission, it's black. So sorry, indirect glossy specular transmission is black. Now this means that there's no information being recorded in here, but we have direct translucency. We have lights coming through leaves, which is direct translucency, and nowhere here is there an option for getting direct translucency out. So if we open up this refraction, just pop that open, you'll see at the bottom of all these there's something called a light path expression. Now this is the formatting of a standard regular expression with what the layer contains. So in this case it would be light, anything plus, transmission, glossy, specular, eye-ray. Now I'm not going to go into a complete run through of light path expressions. It's something that lends itself to being read as opposed to, you know, me sitting here talking you through it. But it's basically a regular expression where you get to denote exactly what you want in the pass. So if we look at the direct diffuse, this is light, and then this is diffuse, this is reflected. So this is light from reflected diffuse viewable by the eye ray. So that is a direct diffuse. Indirect diffuse, you know, direct glossy specular. And as I say, do a search for light path expression and you'll find a document that was published by NVIDIA, who do mental ray now, as you probably are aware, and they do a whole sequence on light path expressions and what you can do with them. The idea is to make everything use the same light path expression, so you can go into a completely different rendering package with the same light path expression and get the same path out of that as you would need for Maya. But for us, we need a direct transmission, or we need the diffuse transmission, sorry. So I'm going to just retitle this layer because we have no refraction on this, or I could use one of these empty layers, or I could add another one entirely, but you know, I've got one here that's not doing anything. So I'm going to copy that. I'm going to call this one direct transmission. In fact, I'll call it diffuse transmission because that's what it is. So I'll just copy that from up there and call this one diffuse transmission. Then I'll go here, call it diffuse transmission up here. Now it's going to use the indirect glossy and specular buffer. We've got it handy and we're not using it for anything else, so why not? And we're going to need a light path expression, which would be in this case pretty similar to the one here. So light dot plus, and we want this T transmission, but we don't want the glossy and specular. This time we want the diffuse. So light dot plus transmission diffuse I-ray. Now that should do it. That should now go from being a indirect glossy specular transmission to a diffuse transmission, which will record the translucency for us. So as I said, this new render path system, it takes a bit of getting used to, and definitely go and look up light path expressions because you'll find there's a ton of stuff you can do with them and thousands of ways to get information out of this. It's so much more comprehensive than the old system. It's definitely not quite finished yet. I'm still noticing a few bugs, but really much more like V-Ray's render passes, which is not a bad thing. Right, so now I've done that. Under diffuse transmission I will have this, so I'm going to have to do a re-render, which is again why we do a small test one first, and I'll re-render and I'll be back in a second. So realistically for the re-rendering I'm just going to go up to render and batch render. First of all, not forgetting, I'm going to turn all these off. No point re-rendering the AA, the volume and whatnot. So render, batch render, and I'll see you back in Nuke in just a second. Okay, welcome back. So my other render finished and I'm going to open that up. Now I've put this in a different file just so we can have both of them at once. And now I'm going to connect this up to Viewer 2, and you might have to reload it. Nuke caches images, so you might need to forcibly reload. It'll have the same name as this one, so you know, just in case it gets confused, just whack that reload button. Now we're going to look here. We've got a direct diffuse, we've got a direct indirect glossy, direct glossy specular, but we've also got this diffuse transmission that we are lacking in this image. So let me just connect this one to the viewer, disconnect there, connect it. There isn't one. So we've got an extra pass now. We've got diffuse transmission here, which gives us this, which is the missing information from this image. Whoops, let me connect those viewers up correctly. So it's the missing information from this image, and in fact if we unhook this, so I'm just going to delete it, put this one in its place. So let's connect up our shuffle nodes. And let's check this out. Okay, so there we have the image. And let's zoom in on the tree here. So this is this one. And now on Viewer 2, I'm going to put this RGB. And here we go again. We've got much darker undersides here. Let me get a better example. There we go. So there we are. Where are those two leaves? We are about there. So this is missing something, and we now know what that something is. So let's get another shuffle node. Put it up here. Hold Control. Get it a bit neater. And this time we're going to diffuse transmission. RGB. Let's give it a name. D trans. and we're going to need a merge node. Let's hook that in. So B, A over B, and plus. And let's connect this to the viewer. There we go. Now, apart from the sky, our two images are identical. So we have successfully recreated our master beauty pass. So direct diffuse, indirect diffuse, direct glossy, indirect glossy, and diffuse translucency, or diffuse transmission in this case. So we've got that light transmission coming through, which pretty much gets us back to where we should be. Now if we disable that, you'll see, hang on, let's just check what is going on there. Okay, there we go. And that's viewer 2, and that's viewer 1. Okay, I just noticed a slight discrepancy here. No, I think it's just my eyes playing tricks on me because of the background being a much lighter color up here. It makes the contrast look a bit different. So I think we have successfully recreated our master beauty. We were just missing that diffuse transmission there. Okay, so I'll be back in the next part. Now I've recreated my master beauty and I'm happy with the result. As I said, we were missing this from the first one, but that is okay. So we've got that on the grass and on the trees and leaves there now, nothing on the house. There might be a little bit on the house from that ivy where it's caught the light, because we've probably got a translucent or transmissive layer on that ivy leaves as well. So now I have done that to my satisfaction. I'm going to just render out a bigger image. Now I don't want to play around with another test. I'm going to just go straight to a much larger image. So for this I'll just go up to full HD 120, and I'll probably go higher. Actually, let's just go straight to 4K, why not? So let's go to 3840, and we want to maintain, actually we can't now, so that'll be 3840 to 160, I believe. So that will give me 4K basically, or 4K widescreen resolution. So I'm going to do a really big image. Now I wouldn't do this for the animation, but for the still shot I'm prepared to have quite a long render. I reckon this will probably take as a still a couple of hours. Now I'm going to go up to the quality and I'm going to increase that to 0.6, let's say. The higher this goes, the longer render time you'll add. Now, legacy options, let's go to a final gather accuracy of 60 and a point density of 0.2. And that's about as far as I'm going to push the quality on that. Now, scene, we've got our passes, we've got our new diffuse transmission pass. We don't need anything else. We've got a depth, which is good. And we've got our image base lighting. Now we could tick the environment light, but we know it's going to take, almost twice as long to render. So that entirely depends on you. If you're going to leave this to render overnight, or if you've got a spare couple of hours, at this resolution, this is going to take a while. So whether you want it on or not, up to you. I'm going to leave it off for this test, I think. And then we've got these we need to turn back on. In fact, let's get the best image that we can. So let's flick that back on. Why not? I will do it so you don't have to, and then you can see the result. So let's just check everything out here, because now we're doing a longer render. We really don't want to get anything wrong. Again, one of the reasons for all the tests, and let's just make sure we're not rendering out a bunch of map passes. we are not. I'll have a quick material check, and let me just make sure that I'm just going to select a couple of these at random, so that's all on, yes. And the tip emissions are off, that's fine. Let's just check the leaves. So there we have that one, that's fine, and that one is fine. So that's a couple of random checks just to put my mind at ease. Okay, and I'm going to change the project directory, and I'm going to call this images tutorials large. Accept. So this will give us much more information to work with, and obviously during post-production you want the highest quality image you can get your hands on, and generally the bigger it is, it's better to work with a bigger image and then down sample it. If you render this out at 1080, let's say, then what will happen is, you'll render the image out at 1080, you'll do the post-production at 1080, and you'll probably display the image at 1080, which is fine. If you do it at 4K and downsample it or downscale it to 1080, it's going to look better. So, again, it comes down to render time. With a single image, I'm prepared to give it a while. So that's all good. Now you can just hit render and batch render. Okay, so that's it from me for this part, and when we come back we'll look at composite in the full 4K image, and that will be our still image, after which we'll look at the animation. Now we will be using the same compositing for the still and the animation. The only difference is the animation will have to have an animated background on it, whereas the still shot composition can have a still background on it, and we might notice there's certain flickering within the animated one that we'll need to clean up in post and things like this, but generally speaking the color correction and whatnot will remain the same over the still and the animated image. So I like to generally work on a still file just to get a general idea of color, and then I'll move on to the animation after that. So I hope you found this worthwhile, and I will see you in the next part. Thanks for watching. Hi, welcome back. So I'm back in Nuke, and I've loaded in my new render. So we're at 4K at the moment, so if I zoom in to 100%, you can see we've just got a bigger image to work with. Now, if you're rendering out an animation and you have the hardware for it, obviously the bigger you can go, the better. For me, generally I reserve 4K for a still shot, and we're at UHD 4K, which is 396. Let's have a look. S for project settings, so we are at 3840 by 2160, so UHD 4K. Now click anywhere here and hit S to bring up the project settings, and you're going to need to set your full size format to this. By default it's probably on 2K or something, so make sure your format marries up here. Now this other image was a panorama image that I went to my local park and just shot the other day. We may end up using a slightly different background image, but this one's in here just to give us something to work with for now. Okay, so apart from this image, which rendered out again with all our passes, the depth and the transmission, diffuse, specular and whatnot, as well as the map passes, we also rendered out our own, let's have a look, and I'm going to read these in from my project directory. This is the directory for my panorama, so let me just go to my project. Okay, so under my project I have all these other render layers that I'm going to bring in. So the master layer I've got here, the volume fog I'll bring in, open, so there's the fog, and now hit R again to create another read node, and now I'll bring in the anti-alias depth just in case we need it, which is here, and I'm going to hit R again and bring in the, so what do we need, the ambient occlusion. There we go. So that's it, all the data that we got out of Maya, plus a background image shot. So first things first, let's just shelve these up here for a second, and I'm going to break out the render passes. These are the render layers, now we need the render passes. So once again, shuffle, and we're going to need 5 of these, I think. So 1, 2, 3, 4, 5. and we ended up with 6. So just unhook it and delete and unhook all of these from each other. Okay, now we need to add them to the image, and this is the same as we've done before. There's nothing really different here. Just going to shuffle out our passes into the RGB channel. So I'm going to move the viewer up here. And first one, we want direct diffuse. Second, you're going to end up with a lot of nodes in Nuke, so you are better off renaming as you go along. So indirect diffuse. And this one will be the direct transmission. And now we should have the direct glossy specular. So always to RGBA. And the indirect glossy specular. There it is. Okay, so that's our 6 passes, or not all of the passes we generated, but the ones that will go into making up the master beauty again. Okay, now we need 6 merge nodes to get these all together. So let's come here, hit M for merge, 2, 3, 4, 5, and 6. And I accidentally hit S on the keyboard there, which is why the properties came up. So unhook all these. And once again, connect all the A channels to the shuffle nodes. And then all the B channels to the node lower down on the chain. And finally, this background into this A. Now, at the moment, and I'm going to use a constant as well. I'll show you what happens when I don't use a constant. You'll notice that my image has shrunk to the size of this background, or in this case grown to the size of this background because it's bigger. If I insert a constant here, you can use a reformat node, many ways to do this, but I like to have a constant that's the same size as my scene. So I know where I am, it just makes sense to me. So there we go, we've got basic composite together with all the passes. Now at the moment it doesn't look like a lot because what is happening is all of our merge nodes are set to over and we want to composite with a plus operation. So, and you can see it slowly come back to life here. And now you can see my background image come in. So just set this one to, this one should be over actually, because it's over the background image. Okay, so if we remove the constant, you can see that everything gets a bit messed up. Okay, and our background image will need moving, but let's just remove that for now and we'll just check all our layers have gone together successfully, which they appear to have done. Let's just check the main image. So I'm just going to hit 1 to transmit the main image to the viewer, and then 1 to transmit the passes to the viewer. And that looks pretty similar in this case. So that's good. All of our passes have gone together. Now we just need to sort out this background. So in this case we're going to go A over B, and there would be the background. Whoops, sorry. B over here. And this is not right. The front image here, this node chain, should be over this image. And because it's not, it looks like we've got a problem with the alpha channel somewhere along the line. So I'm just going to check all these shuffle nodes have been set to RGB and not RGBA. First one in the chain, sod's law. So set this to RGB and the background will appear behind. But the background at the moment has been resized to be quite miniature, and this here is just an artifact of that. So we need to put a transform node into this background so we can move it, transform, and you'll see I've got this little handle now, and now I can kind of pull this around and scale it. So I can then really just decide where I want the background to be. Now for the moment that's not too important. Let's just scale that to give us a bit of sky up there. There we go. So now we've got something we can basically work with, and you'll notice this stays on the screen. If you want to clear up this node chain and any artifacts it leaves behind it, just press here and we're gone. So now we've got a sky. So now we've gone from this to this, which already is a mite nicer. So that's the basic composite. Now we need to get the ambient occlusion in there. Now we could just multiply this ambient occlusion across the whole node chain, but that would really be the wrong way to do it. Ambient occlusion wants to be multiplied realistically with the direct diffuse or the ambient pass, and we don't have a ambient pass for this particular render. So the best we can really do is take it over the direct diffuse. So I'm going to pull this direct diffuse out of this node chain for now. I'm going to take a merge node and I'm going to merge these together. Okay, so I'm going to put A for this one, B for this one. The direct diffuse, of course, will still be connected to the image. And then I'm going to take this and put it on multiply. Okay, so if we take a look at what that looks like, this is the direct diffuse with this multiplied over the top of it. And if I double click the merge 7 node, I can make more ambient occlusion or less by tweaking this. I could also put a grade node or something else in there. Now I can just drop this into the node chain and have a look, and there we have a ambient occlusion all the way over the image. And just check that that hasn't screwed up anywhere on the background. Nope, so that's fine. Okay, so sorry, I find it a bit troublesome using this view here, not on another monitor, just because I've got so used to working on multiple monitors with Nuke. But so there we go. So now we have a slider to control the amount of ambient occlusion that we're going to get, and of course we can mask that out, which we probably will do at some point. And this is a bit of a mess now. So I'm going to just click this merge node and call this DDAA, direct diffuse and ambient occlusion together. I'll move this one up here, this one here. And remember, you have a lot of room in Nuke. So generally I try and keep my node chain as neat as possible. You can use control to sort of bring one of these out. There we go, just so I know where that's all going. And this looks pretty decent at the moment. So, the reason I are quite fastidious about trying to keep this neat is as we go on we'll end up with more and more nodes, and I like to see what's connected to what. So to do that, I'm going to move all the merge nodes down this side. And this way it'll give me a clear pipe. I'll show you what I mean in a second. Let's just move all these, give them a bit of room in between each other. And then I'm going to use the control key to straighten them up. And this for me, I mean everyone has a different way of doing it, but for this for me I quite like, because this is now the direct diffuse plus ambient occlusion and the indirect. So if I want to drop, let's say, a color correct for the direct the direct transmission, sorry, small brain freeze there. When I drop that node in here, so let's just go grade, I can easily see that it flows down this pipe over to there, which is the merge node here. So it gives me some easy way to kind of drop color corrects and grades in here. Now, and also it's a nice pattern to kind of follow down and see where things are going. So let's do a quick grade of the diffuse transmission, and a good way to do this would be by looking at some of these leaves. Now let's get a bit of a zoom out. and this will grade the whole thing. So obviously that's not good. Let's just remove the white point and just do the gamma. So you can see I've got control over that. Okay, so that's the basic composite pretty much taken care of. Now we would need to apply the depth, we'll get into a bit later, and the fog, which is here. Let's just press 1. You can see I've got that volume fog there. Now for me this would go at the end of the chain because the image is foggy, so the fog would be over everything. So let's come down here to the end of the chain where the viewer can be as well, and let's add another merge node. Now this one will take this as B and this as A, and this one will be set to screen, and let's have a look at that. Now I've got that fog over there. So less fog, more fog. So depending on how much atmosphere you want to give it, and of course we can come in and grade this fog. I'm just going to stretch it out there so we know where everything is. Background image, ambient occlusion, main image and main layers, and depth. Now talking about depth, before we go any further, let's put the depth in the node chain. Now this is generally not something I would do until the end, but I want to give you guys a look at how this is going to work. So I'm going to hit tab and hit Z. Z depth. In fact we should have Z defocus, sorry, not Z depth, which we'll use for depth. And I'm going to drop it in here. And you'll see this whole thing will just go blurry. Okay, now I'm going to set the Z depth to depth channel. Now we actually have a depth channel, which means if I go to result and do a focal plane setup, you'll see that we have this blue, which is everything out of focus. So let's go back to the result. Sorry, let's go back to the focal plane. And now I should have in here a focal point. There it is. I was just missing it off the edge of the screen. So when I move that, let's go to the focal plane setup. You'll notice that nothing is happening. I'm getting absolutely nothing here. So let's check in the viewer after we come out of this Z depth if we still have an actual depth. And we don't seem to. Just RGB alpha, but no depth. So I'm getting no depth through there. So we have to pipe the depth through this lot as well. So I'm going to come up here and I'm going to do that right now. Okay, so our first problem here is this has no depth, obviously. This is just a photograph, so that means this one in the node chain won't have depth, and this one in the node chain won't have depth, because this is simply a shuffle out in this. And if we grab this and tell it to also merge, let's say depth, you still won't see any depth, because there is none. It's coming out from this, 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 and this, which are just RGB channels. So let's put that also merge to none where it normally is. And let's come in and instead of a shuffle node, we'll use a shuffle copy node. That will allow us to copy one channel to basically, rather than just shuffling out one, it'll allow us to shuffle out a copy of one. Okay, so hit tab and just shuffle copy. Now let's put this in the node stream. You can just drag it in there. That will connect to. So input 2 up to the stream. There we go. So that's interspersed in there. And now grab number 1 and move it to here. Now we know there's a depth in this. We can see it here and we generated it ourselves, so we know it's there. So we need to copy out the depth into the output here of depth. I'm going to tick here so it's not copying out the red, but it's copying out the actual depth. And then when I hit 1 on the keyboard, you can see we've got a depth layer here. So if I go down to the next node in the chain, if we follow this down all the way to the bottom where the viewer is, and I click this and hit 1, I've got no depth. Now I can double click the merge node, also merge depth, and you'll see I've got a depth. If I click the next one down, I've got depth, all the way to our Z defocus, which if I put this viewer back on RGB, you can see now the result is going to come in. Let me flick this to go away, you output focal plane setup, and now we've got this focal point we can move around. And as you can see, because we have a depth, now we have a depth. Now, both blue and red are going to be slightly out of focus depending on where they are from the camera. So now we can use this depth of field slider to get some perfect focus in the image. So, you know, the bigger this is, the bigger your field of focus. So for instance, if I put this here, that'll give me a focal point right in front of the camera, and this will start to be very blurred. So let's focus in on the house, because that's where our main focal point is going to be. Set the output to result, and I'll just make this a little bigger. So if you click on the viewer here and press spacebar, you'll get that to be full screen. Let's do a zoom in, and I'll just let that calculate. This is a 4K image, so it takes a couple of seconds. Okay, and now you'll note we've got a background that's very blurry. As you can see, these trees here are starting to blur out. We've got a foreground that's a little bit blurry, a tree here that's in pretty sharp focus, and a building that's in pretty sharp focus. If I move the focal point, you'll notice this grass goes back into massively in focus, and as we get towards the house, you can see it blurring out there. So our depth pass seems to be working reasonably well. And I'll just let that blur in for a second. So, you know, now we have fairly decent control of our depth of field, and we'll play around with this more later. There are some options we can go through to get a slightly faster blur. For instance, the amount of blur here is a bit extreme, so pressing spacebar to get back to the thing. We could lower that with the size here. Now the size is going to control the amount of blur that you get. So if you crank that all the way up to 100, let's say, you're only actually going to get, in this case, a maximum blur of 10. If you want, it doesn't matter that this slider goes over, you're only ever going to get a maximum of 10. So if you want more blur, you're going to have to pull the maximum up. And then you've got things like the type of blur. Do you want the blur to bloom as well when it hits a bright spot? All of these are more with the artistic impression of the blur, the bokeh, if you like. But for right now, it's enough for us to test that that blur pass is working, and we can pretty much see it is from here. I can see it coming in very blurry here and extremely blurry in the background. Because we've got that blur size up to all the way up to 10, we're going to get a pretty decent sharp focus. And again, if we get a focal plane set up, if we reduce the depth of field, get a focal point right on this edge. There we go. So just this is really in focus. Now we've got a bit of tree in focus there, which must be pretty much exactly the same distance as this. Turn this back onto result. Spacebar to get a bigger one, and I'll just pause this and back in a tick. And there you can see I have some pretty extreme depth of field. We've got real blur going on down here. These leaves are all blurry. The background is super blurry, and the house is in really sharp focus. So this is not an extreme I would go to, especially with a shot like this where there wouldn't in actuality be that much blur. But it does show you what's possible with that blur pass that we did. Now we could also drop in our blur render layer that we did. So if we go back here and have a look, we've got this blur render layer that we haven't used yet. I'll introduce that at the end and just show you what the difference is, but it'll do pretty much the same thing. So let's come down here, select our Z defocus and hit D. This will disable the node. This is because I don't want to, say, add a color correction in, or this grade for instance. When I tweak this grade, I want to see the results instantly, and if I have that Z defocus left enabled, it will try and defocus that again every time I tweak this, so it's not something that you want on there. I'm also going to come in and disable the fog, because when I'm doing the color correction I'm going to want that off, and then to get rid of this focal point I'm just going to come up here and click go away. Okay, so this leaves us, let's just check, and this grade node. So if you want to get rid of this grade node, you can just hit delete. But I'm going to leave this one for now, so I can grade it. And generally I would have a grade node on pretty much all of these. And I want a grade node on this, let's see, on this ambient occlusion. I want to be able to grade it before it's multiplied. And the same on this. So G, by the way, on the keyboard is the keyboard shortcut for grade. And then I've got this rather unattractive thing here, so I'm going to pull that out. And again, you can't always get it perfect, but let's get it sort of somewhere in the ballpark, just so I can see more of a glance what's going where. So I know this is being piped out into a shuffle copy, which we'll call depth. So I can see quite clearly where that's going, and we have this direct diffuse and ambient occlusion, which is pretty much the start of our node chain apart from the background. So that brings us into the basics of getting the image together, getting our fog, getting our Z-blur, in this case our depth of field, and we are done for the basic, the very basic getting the image back together. So in the next part I'll be back, we'll look at some color correction. This grass is way too green. The image overall is too saturated, it doesn't have enough contrast. I want to start tweaking some of these trees in the background so they're a bit of a different color and they match the backing plate a bit more, and this path is not contrasting enough, and etc, etc. So when we come back we'll look at some ways we can alter this image, make it a little bit more dramatic. Alright, so I'll be back in a moment. Thank you for watching, and I hope you pick something up from this. Cheers. Hi, welcome back. So in the last part we set up our basic node chain here, and for this part I've gone ahead and disabled a couple of those. I've disabled the ambient occlusion, so just select the node and hit D to re-enable or D to disable. I've also disabled the Z defocus and the merge for the fog. It's just because we don't want a lot of that cluttering everything up while we go ahead with some color grading here. So one important thing we need to go over before we do any type of color grading, and that's pre-multiplication and un-pre-multiplication. Now a pre-multiplied image is an image where the alpha channel has been times by the RGB channel. Now Maya does this by default, so this image has already been pre-multiplied. This is why when we overlay it on a background like this, it obeys that alpha channel and we get everything looking nice. We can see the background through it. If you look in Maya's settings, I'll just bring up Maya here and we pop open some Mental Ray. If you go to the Scene tab and show Advanced Settings, you can see that pre-multiply is ticked. So anything Maya renders out from here is going to be pre-multiplied, which means that its alpha channel will work correctly. Now this is really down to specifically the anti-aliasing and semi-transparent edges when we do things like color correction. And as you can see, the alpha channel here is working really well. It's kind of perfect. I'm seeing the background through, I'm not getting any kind of artifacting around the edges and whatnot. So everything works. So realistically now, the problem is that if we do some color correction now, we're going to be color correcting a pre-multiplied image, which we don't want, and it's easier to actually show you what's going to happen. So let me select this grade node. In fact, let me select this grade node on the direct diffuse, and let's try a really extreme color grade. Now you'll notice here that there's white edges around everything. So when we've color graded this multiplied image, our pre-multiplied image, we've lost the math that deals with the alpha. We've actually changed it, the way it works, and this is no good. We've got this really nasty edge around everything, and again this comes to working on a pre-multiplied image. So what do? Well, we need to unpremult the image, or unpremultiply the image, do our color correction or our grading, and then pre-multiply the image. Now this can get a bit confusing when you first start doing it, but it becomes more intuitive over time. And if you are seeing this horrible edge here, so if you're getting this, it's probably because you're grading or color correcting a pre-multiplied image. So how do we fix it? Well, we unpremult the image, so we unpremultiply. We take its multiplication math away, and you can see this has gone now really jagged. There's the grade. So we unpremult before the color correction, then we do the color correction or the grading, and then we repremult. And you'll see all those nasty edges have gone away. So now I've got an extreme color correction, but I've got the correct edge flow. And this is because we're unpremultiplying the image, correcting it, repremultiplying the image. So you don't want to do any form of grading or color correction on a pre-multiplied image. You want to work on an unpremulted image. So the other thing you're going to get when you do this is, let's say you've got, so I'm going to remove those, and you can see the nasty edges come back. In fact, if I put those back in, so nasty edges, perfect alpha channel relationship. So that's why we do it. Let me just remove these, and let me unhook this color grading here. So it would get to be quite a pain to come in here every time and put a pre-mult node in, an unpremultiply, and then repremultiply the image every time. So if I go back to this grade node, there is actually a shortcut within Nuke in the color correction and the grades. And this is because we end up having to do this so often. Most renderers render out a pre-multiplied image. In Maya, as we saw, you've got that tick box, so you could render out an unpremultiplied image, but then you'd have to pre-multiply everything. So either way around, you're going to end up doing a bit of work. Now, say again we do I should have just left that, but there we go. We do a grading to the point where you can start to see the alpha channel transparency on the edges being affected, because we're working on a pre-multiplied image. Instead of putting a pre-multiply node, an unpremultiply, and then a multiply node in here to correct this, you can just come down and use the unpremult by RGB alpha, and that does the same thing. So this is basically telling Nuke that we want to unpremultiply this before it gets to the grade, and then repremultiply it after it leads the grade. So it's the same workflow as before, it's just a little easier. And you'll find this on most of the color corrects as well. So if I put a color correct in here, there is one down the bottom somewhere. Okay, so in the color correct, it's in the ranges. So you've got unpremult by. So let's see what happens when we don't do that. And again, this is the same as adding a unpremult and premult before and after. But let's just see what happens if we try and color correct this now. So let's do an extreme color correct on some of these things. Let's go the gain. And you can see immediately the alpha channel's all messed up. Let's go into ranges. Unpremult by RGB alpha, alpha channel not messed up anymore. So that's why it's important. The reason it's often overlooked is because in general most people find it quite confusing. I know I certainly did when I first started with Nuke and compositing in general. And B, if you make small changes, it's not really that noticeable. Normally when you're doing a color correct, you're doing small tweaks. So if we put this to off, you can really see that jaggedness of edge. But if I come in and go back to the color range, I'm unlikely to do a gain of 4. I'm more likely to do a gain of, say, 0.12 or something like this. And you'll notice you don't actually see the fact that it's not working correctly. Now, As soon as I get into a more extreme color correct, it becomes very, very obvious. So the reason why this is often overlooked is simply because with the kind of color correction work you're doing, most of the time, you're not going to notice it. So you might wonder why we go to the trouble. And most of the reason for that is if you ever do need to do an extreme color correct, excuse me, I'm just going to unpremulk this to get rid of those edges. There we go. If you do an extreme color correct, then you will definitely see those jagged edges. But the other reason is you start to stack up quite a few of these grades and color corrects, and small changes stacked on top of each other can also have a drastic effect. So it comes to the point where you're grading away, you're making a small tweak here and a small tweak there, and they're all kind of adding one on top of each other, and then you notice that somehow your image has got these nasty jagged lines on it. The background has been affected by the foreground's color correction, because that will happen too. Now in our case, because we split up all the passes, it's not really a problem for us. But if you just take two simple images and put one over the other by the alpha channel, then without unpremultiplying first, your foreground color correction will start affecting your background, which is just not what you want, really. So let's just bring these, I'm just going to delete these altogether actually, because we don't need them anymore. And now I want to go into masking. So when we rendered this image, we of course created a lot of mattes for it. Now normally I'd see them up here. The thing is that this is viewing this final image at the end of the node chain, and all those mattes are not pumped out. So I'm going to have to go to number 1, and now I can see all my mattes. So I've got, we've been through this before, but basically, let's say I've got this main house matte, and I want to pull that out. So let's go and focus on our main image again. Let's set it back to RGB. So I'm going to use a shuffle, and I'm just going to connect this in here, and I'm going to come up to shuffle out the matte set 1, and I just want to shuffle out its RGB. Now in our case, because it's matte, we just want to shuffle out the red channel, and then let's hook up a grade. And the reason we're going to shuffle out the red channel is we're only interested in the luma of the image, not the RGB, so we're interested in the grayscale for the matte really. So let's get that one over there. Then we take the grade node and we hook it up to the matte. Now at the moment this grade node is still going to pretty much affect everything, because the mask is currently set to RGB alpha, and we want to set it to RGB red, and you'll notice now I only affect the house. Okay, so let's go in and take a closer look. So we can see here our edges actually look okay. Because we're using the mask is going to limit the influence of what we can and can't affect. So, you might think that you would get away without unpremultiplying and premultiplying again. So let's have a look in the node here, and we've got unpremult by none. So let's try RGB alpha, and boom, you can see those edges come right down. So, even in this case, we still need to use that unpremult, premult. And that's going to take place pretty much every time you do a color correction. And as we've already mentioned, one of the reasons that will get overlooked is simply because you only see the result after you start stacking a lot of these nodes on top of each other, or after you're doing a more extreme form of color correction. And the thing is that you only see the result when we get this extreme color grading going on. However, there will always be something that can look a little off about your image, because the influence is quite subtle when you're only grading this much, but you will notice something that looks a little off, and probably the reason is the transparency in the alpha channel as being messed around with, because it's already been pre-multiplied. Right, anyway, so now we've taken a look at masking. So realistically we can now start to actually color grade this house to the point we want it to. So let me do a pretty much a real world example, because I don't want to grade that house right now. Let's take this grass for instance. Now I happen to know that this grass is made up of two different sets of geometry. that's particle based, basically placed in the scene, but I also know it has two different shaders, which means I will have two different mats. So let's have a look. So we've got grass type A, as you can see, and we should have a grass type B somewhere. So this means that I can now take these and turn them a different color, for instance. So how will we go about that? Well, for us, that depends on where we want to get our main color information from. So for me, I want to get that from the direct diffuse. I want to change the direct diffuse color. So here we have the direct diffuse color pipe. Now I'm going to call this mat what it is, a main house. Here's where your node chain can turn into a bit of spaghetti, and I'm not going to spend too much time organizing it on the screen just because it takes a while, and really I'm not going to hand this file to anyone else right now, so it doesn't matter if it's a bit messy. So let's get a second mat out and we'll call it grass type A mat, and I'll just put a mat in front of this as well. So grass type A, so again shuffle out that mat, grass type A, where have you got two? There we are, and RGB, and we only need the red because again we're using a black and white mask. So you could take the green or the blue, either, it really doesn't matter, as you probably figured out by now. Right, so we've got this grade node which is currently grading our house. So let's add, in fact let's shove that one down there, and let's add a grade to this grass too. Now, currently we'll be grading the whole image, so grass. And let's remember to set our mask to RGBA red and our unpremult to RGB alpha. And now I should be able to grade only half of my grass. So let's see. Okay, this grade node is doing absolutely nothing, and that would be because my main image here is set straight to the viewer. So I'm only viewing this. Let's go back and do the whole node chain, and now you can see that my grade node is actually affecting one subset of my grass. So I can now kind of make tweaks and changes to how this grass looks. Now I consider pretty much all of this an artistic choice at this point, so it depends where you're trying to get your grass. You can also kind of change the hue and saturation of it. So let's add a hue shift. Okay, so again mask RGB red and unpremult by RGB alpha. There we go, and we need to tell this hue shift what it's being masked. So let me just untick that mask box for now, so I can drag that up to the grass mat and then tell that that's red. Now I can come into the hue shift, and if I wanted to do, say, a hue rotation to change the color of the grass, there we go. Okay, now rotation across axis is quite good with the color axis set to 1, so everywhere I go this way it will get greener, this way more orange. Now I'm not going to spend a lot of time, overall saturation is of course the saturation of the grass you're dealing with. I'm not going to spend a lot of time going through things like the hue shift node in Nuke, because I'm going to assume you guys have some Photoshop experience, and this works pretty much like the hue, saturation and value node. The same is for grade. I'm going to take it as read that you know what the black and white point do, for instance. This is fairly basic stuff, and if you don't, you can play around with them. It becomes quite obvious. There's lots of information online, but realistically from here on out the image becomes more of an artistic choice. So it's what do you need to mask as opposed to how do you need to mask it. So for me, I'm going to go away and do some color grading on this image. Just simple stuff like break the grass up by giving it different shades. So, and also, remember that you don't have to just correct the direct diffuse. Let's look at this grass, and it's looking pretty extreme at the moment, but you can definitely see there was two different shaders used here. So you don't just have to grade the diffuse. Let's say we wanted to change how shiny this grass was. So we put a grade down here before. Let's pull the masking channel out and connect it to that grass type A. And let's come in here and make sure we mask by RGB red and unpremult by RGB alpha. Okay, now I've got a grade node that will affect the direct glossiness of grass type A. And if I pull the black point on this, actually the white point would be a better choice. You can see now that gets really shiny. So as well as being able to change the color of the direct diffuse, remember that down here you've got the translucency, the indirect diffuse, the indirect gloss, the direct gloss, which gives us a phenomenal amount of control over what we're doing. Now, you know, I can kind of take the shine away from the grass completely. I can add a bit more back in. You know, and there are, of course, nodes in Nuke to sort out problems like this. This may be overexposed now, so I could use a clamp to clamp those white values down. And again, RGB alpha. And let's use, say, a minimum. And now I can clamp the white value, because here, if we look, we've gone way into the super brights. So if you didn't want to, you can clamp it down. And, you know, rather than take you through this process where I sit here and spend the next 2 hours slowly but surely color correcting everything, because like I said, it's an artistic process. You judge it by eye most of the time, unless you're working from a very specific set of references. And for me, I like to actually, you know, grade things, pontificate a bit. You know, it's a process, and it's one that is entirely dependent on what you want your final image to look like. Now I'm going to go for a kind of grey skied, foggy sort of haunted house type of look. Maybe not quite that extreme, but definitely not a bright sunny day. So you might want to do a bright sunny day, you might want to do an overcast day, and all these things are possible at this point. It just depends on the artistic choice you're going to make for the image. Now, so as I mentioned, I'm going to go away and actually get on with this. So then we'll come back and look at some of the nodes that I used. Basically, I'll be using the grade, the color correct, and probably the hue shift, and that will be about it. So one other thing before I go though, we did this house map, which was, if we look at it, the house and the roof joined together. Now we did that in Maya by the use of its new matte channel function. So if I pop open Maya, we'll have a look here, and we've got passes. Now we've got this use matte passes, and we went in and created a matte pass material set, and doing that allowed us to merge the house and the roof. So, you know, this has worked out fairly well for us to get this. But let's say I've got this grass mat, and that allows me to grade this grass. But what happens now if I want to grade both grass at the same time? Well, I said in the tutorial that you could make your own sets, so let's just do that before we go. So I need to shuffle out the other grass. There we go. Let's come in here, shuffle that out. So RGB to RGB alpha, sorry, grass type B to RGB. Just need the red there. Okay, so now I just merge these two things together, A, B, and I'm going to use a plus. And if I look at that, that's both mats together. So if I take, let's say, my grading from the direct diffuse here, and connect that to this, and then finally connect the whole thing to the viewer, you can see that this grade node, where are we? And I said now we get a bit like spaghetti. This grade node is now affecting the top and bottom grass together. So, you know, you don't have to use an individual map for everything. You can, of course, use one matte, or because you can see I'm definitely affecting all the grass here. So you can of course merge mattes together to create a matte set yourself. So if you haven't done it in Maya, there's no need to think, oops, need to re-render. You can just simply put that together in Nuke. Right, so I'm going to go away and work on this composite a bit till I get something I'm happy with. Then I'll come back and we'll discuss, what was put where. And we're also going to need at some point to bring in our animation. So I'll be back in the next part, and I hope you found something in here useful. Cheers. Hi, welcome back. So in between the parts I've done just a little bit of grading to this image here. So I've changed the color a little bit, I've desaturated it, and overall I've given it a little bit more atmosphere. Now this is the ungraded image, the raw render out of Maya, and this is the one I've just done here. So I haven't done anything I haven't already been over with you, and I'll get into the node chain in a second. Just really small tweaks with color correct nodes and some grade nodes. So the background has been a little desaturated as well. And we've got just a little bit of blur here. Now I'm having to use quite small size windows, so you probably won't be able to see the blur that well, but we'll zoom in and get into that in a second. So the node chain, I'll just pull this window up so we can take a look at it, is pretty similar to what we had before. Here you've got your direct diffuse, your indirect, and all the nodes we built with the grade nodes on them. Over here is the background and that depth, so we're just piping the depth through. So really it's the same. All I've done is move that rat's nest of masks that mattes that we pulled out over to here. So I've just neatened that up a bit, and then anything that needed a mask, so this would be the direct glossy specular contribution, I've just pulled out the mask from there. So this is the merge node we used to merge the grass A and B mattes together. So that's going into this grade, which goes into the clamp to make sure we don't get those very bright hot spots. Then we have a grade here that, if we trace that back, goes up to the tree. Now this was one of the trees that we had. We've got a path map which we can just trace down here and see that goes to a color correct node under the direct diffuse. So you can always trace these back. Now I've also graded the ivy a little bit, used a color correct on that. So the ivy has a color correct on the direct gloss and also a color correct, you can see it feeding in to the same mask here on the direct diffuse. Now, other than that, I haven't really done a lot. So it's the same principles as before. We're unpre-multiplying all these grade and color corrects by the alpha. So if you'll remember, under ranges, unpre-mult by alpha. And if I pull that out a bit, you can see the masks are just RGBA red. So this one, just the luma, really. Same with all of these. So as we did in the last part, I've just added a few extra nodes. So what I came up with, my idea for this image was just quite a simple overcast desaturation, in comparison to this one, which is a bit bright for my tastes, but I could have gone brighter, I could have gone overexposed, and this is a fairly low-key color correction, really. I haven't actually color corrected that many things. I haven't really used that many masks. We've got some masks that we haven't used, and really things like the diffuse translucency I haven't graded at all. This one is just set as it was. The same with the indirect diffuse. The grading on that for the whole channel has not been changed. So there is other things that you can tweak there, but I'm really going to leave that to you. I'm quite happy with this shot. I'm going to press the space bar to bring it up a bit bigger, and there would be kind of my final shot. Now you can see we're a little bit blurry down at the front, but we're really not overdoing that blur. The background here is blurry. Now I do have a color correct on the black background, where I've just basically, as well as desaturating it, I've changed the colors slightly. Let's have a look. So the background here has a color correct on it. Now you'll notice that I'm not unpre-multiplying the background by its alpha channel because it doesn't have one and it's behind everything else, so we shouldn't need to. And I've just used a bit of gamma on here which made these trees in the background darker and made them more in keeping with our trees here. Now one thing that I wasn't particularly happy about was that all of these trees that I have done in the background have the same material, so I had one map for them. Now I could go into Maya, make a new render layer and make a map for just one tree. In this case it's not strictly necessary, and a better way to have done this would have been to duplicate that one material within Maya, and then when I rendered it would have created a map for me automatically. So I could have gone in and tweaked, say, this middle background tree's color a little bit. But it's a small thing. It's just a possibility. So that leaves us with a final scene, but for a still image. So we need to talk about the 3D image, because when the camera moves, the background's going to stay where it is, which is just going to make the whole thing fall apart completely. So when the camera moves, we need the background to move, obviously. So we'll look at doing some 3D composite in Nuke. Before we go any further into that, I'm going to really blur this image. So I'm going to go down to one viewer. I'm just going to move this out of the way. There we go. And I'm going to pull the big version of this up. And I'm going to follow my node chain down all the way to the bottom until we get to the ZD focus. We've got our focal point set up there. If we look at our focal plane setup, you can see the green is all in focus, and then we've got different blurs moving away from the camera. So if we come in and get the result of that, you can actually see this is a little blurry down here. If I just hit D to disable that, you'll see it go into sharp focus. And the same, I have to let it calculate, can be said of the background. It's a little blurry, but it is, a fairly small amount of blur, which is probably fine for a shot like this. Well, it's definitely what I would go for, just a tiny bit. So if we take the size and we crank that all the way up to 10, you'll see obviously you'll get more blur. Now I'm just going to pause and let this finish out. There is a point to this. I'm not just going over what we've been over before, so I'll be back in just a second. Okay, so that finished off with it, and you can see here, because we're using a non-anti-aliased blur as we should be doing, this doesn't look particularly nice. Now this is probably always going to be a problem with really extreme blur, unless you calculate that within Maya itself. If you let Maya do its own depth of field, a true 3D depth of field, you're not going to experience this problem. So if you need a really extreme blurred effect, it's probably better to calculate that in 3D. But it still holds up quite well. It's not tragically awful. Because we're working on a 4K image, the fact that we have no anti-alias in is not really that bad. Now if we were working on a much smaller image, or if we were working in a package like Photoshop instead, we'd want to use that anti-alias blur. Now you'll get people that swear by both types of depth mask, and I've seen lots of arguments on the internet. But my take on this is I use the one that works for the situation. Now in this particular situation, the depth generated by Maya's render passes work just fine. Now we rendered this anti-alias one, so there it is. And let's swap it out. Let's use that instead and see what difference it makes. So I'm going to unhook this depth from here, and I'm just going to shove that over there, just because we might hook it up again. And I'm going to do the same with this image. So this is a shuffle copy, copying the depth out back into the depth channel, so we can pump it through here. Now I'm going to copy out the luma of this. So let's go shuffle copy again. So there we go. And I'm going to set that to number 1. Shuffle copy. I'm going to shuffle out the RGB, and I'm going to shuffle that into depth. So I'm going to have to go to other layers, depth. If I hit 1 to put this up on the viewport now and go to depth, I should have there a depth layer. Aha. But I do not. There we go. Now I've got a depth layer. I could also do this with red, doesn't matter, just from the RGB to the depth, but we don't need the RG and B, we just need one because we're dealing with black and white. So you can see this shuffle copy now contains depth information. So there we are, back on the RGB, and this should actually contain nothing now. Okay. Let's see what has gone wrong. I have got these two ticked over here, which we did not need at all. So one in and out is depth, and none and none. There we go. Let's go to the depth channel. There, done. Sorry about that. So basically we're taking the depth out here from the RGB here and hooking that up just back where this depth was. Okay. Now as we come down, you can see a little purple dot, meaning we've got a depth channel on here. So I'm still on the depth layer. Let's go to RGB. And you'll see the whole image will be really blurry. This doesn't mean it doesn't work, so don't panic. What that means is just this is set to the old values. So if I set this on focal plane setup, the whole thing will just be blue. It doesn't know what's going on. If I move the focal point, you'll see that that does a rereading and refreshes, and so we get this back. So now we're using the anti-alias depth that we generated. We're not using the depth from Maya, which would be here. We are now using the one from this. So let's go on to result. So focal plane setup, result, and we've got an extreme blur, so I'll just pause. Okay, so that's calculated out its depth, and let's take another look at these leaves. Now they don't have so much of the jagged anti-alias leaves on them, but then they start to have other issues. But in my humble opinion, this anti-alias blur can look better on a still shot, especially when compositing with something like Photoshop. So, and you're normally not working, or at least I'm normally not working at 4K, and the anti-aliasing on the Maya depth can really start to show up then. So that's the reason we generated this depth. If we go down and find the depth of field, and as you can see, multiple monitors for Nuke are definitely an asset, and change this to a much lesser blur, like we might use, because this is a kind of extreme blurring. You'll find, for me, the anti-alias depth gives a bit of a more natural feel to it. Now, the reason people don't like it is because if I was to animate this now, we'd probably run into all sorts of problems with the edges. On a still shot, you'll be absolutely fine. On an animation, you're gonna run into problems most probably. I mean, again, it depends on the image and what it is you're blurring, but in general, you're gonna run into a few problems. So really, you can now use either. We can take this shuffle copy, which I'll just give a name to, depth AA, and I can unhook that one. Just bang it down there when we want to use it again, and rehook Maya's depth. There we go. Now every time you do this, you'll have to go back down to the defocus and just move the focal point a little bit, and that will come back to life and recalculate the depth. So there you go. Completely up to you which type of depth you use. You know, I decided to generate 2 in the tutorial because I'm sure a lot of the times you're just going to want to do a quick slap comp in Photoshop, and for that the anti-alias depth will generally always be better, unless you're working at sort of massive resolutions. So I just wanted to give you the option. So I will include this Nuke file labeled still shot with the tutorial, so you can just go and have a look in these color corrects, but really there's nothing, you know, it's very small corrections to things like gamma and color saturation, so there's nothing there that you won't be familiar with, I wouldn't have thought. You know, we've got some overall saturation here. There is one thing, I do have a mask inversion, which is kind of cool. just means you're going to invert the mask, so you're going to correct everything else. Now if I take a look at this main house mask here, I've got one correction node. I've got one color correct that's using the main house mask to do the whole environment, but not the main house. You'll notice it doesn't change color. I'll just disable the defocus. So this way I could get a pretty much almost black and white environment. Well, I could get a black and white environment if I wanted one. So there we have one for the environment. There you go, massively oversaturated. And this is because if we take a look at the mask, it's on invert. So it's using everything but the house. And then here's one for the house, which is just using the house. So again, black and white house, colored environment. So just that invert of masking, I'm sure you've done similar in Photoshop, come in a bit handy. There you go, if you wanted, say, a selective color. Now I've got a black and white house and a full color environment. So again, really haven't done that much here. Let me just crank this back to where it was and probably saturate this house a little bit. There we go. So really haven't done a lot here. Our volume fog is still the same, and that has a color correct on it too. So this now looks like this. The background is a lot more saturated with fog, and that's done just by pumping up the contrast a little bit under the master channel. So that is it for the 2D image. Now for the 3D render, I'm going to go into Maya, and I'm just going to want to discuss how I rendered that out, because I've got all the frames out now. So I'll just save this beastie and pop open Maya. Now this is our scene from Maya, where we got all our render passes out. Now the same thing applies. To render the animation, I'm simply going to hit render and then batch render, and that will render out all of these for me. Oops, hang on, Maya's had a little bit of a pause there. So just render, batch render. Now, depending on the machine you're rendering on, whether you're rendering over a network or whatnot, this is going to determine the time taken per frame. And remember, you're going to have to turn these on. What I generally tend to do is turn off all the sundriest layers, the anti-alias depth, the volume fog, and the ambient occlusion, and render out just the master layer first. That way, if there's a problem, I haven't accidentally rendered out a bunch of surplus layers. My settings for this were quite simple. I used an overall quality of 0.6. Everything else remained the same. On 1, I used final gather, and my quality settings for final gather were accuracy of 100, point density of 1, and point interpolation of 10, with 2 secondary bounces. So that was it. Now I would mention that I did mine on a network, so if you find the file to freeze, that's because I calculated out this primary gather file. But really nothing in here that's terribly complicated. So batch render, when you've got all of your renders out. Now I'm going to leave you my renders as well, just because this is a fairly lengthy process. I think I rendered out at 720. So not the full 4K for the whole animation. Would have taken a bit too long, so I did a HD 720, and that took probably about 40 minutes per frame with all the sundriest data. So it's a long render. There's not really a lot you can do about that. If you're going to render environments and houses and complicated geometry, things like lots of grass, and you want a decent quality, then it's just going to take some time. So you can send it out to one of the render farms. You can do it at home if you've got more than one machine. Use Mental Array Satellite. There is a few ways around it, but unfortunately no way around the fact that these things just take a bit of time. So before we go, I want to export my camera. Now I'm using the perspective camera on this, as you can see, and it's just got a simple keyframe on it. So if we look under the perspective camera, you can see everything's been keyed. Basically, to create the animation, I just got the camera into a position I liked, selected it, hit S to do a keyframe, keyframe everything, and move to the last frame. Let's just jump there now. put the camera in a slightly different position. I didn't do too wild of a movement because with all the little pieces moving around, I wanted you guys to get a good look at that. So, you know, I could have swayed the camera in a 360 or done pretty much anything I wanted to, but I just did a very small movement. So as soon as I got to the end frame, I moved the camera, hit S to just do a quick keyframe, and that's this animation basically. So, you know, in order for us to match this in Nuke, we're going to need to export the Maya camera. So if you just select it over here, whichever camera you're using, if you've created your own or using the perspective, and then we need to export this to Alembic, and that will export the camera movement into Alembic, the whole camera, and then we'll open that up in Nuke, and then we'll be able to put geometry in Nuke to put the background on. So before I go and close Maya down, let's do that. Now you want to go to Window Settings Preferences, Plugin Manager, and make sure that ABC Export is ticked. Now if you followed me around on the other volumes, you'll know this is the Alembic export. Make sure we're selecting that camera and just go up to Cache. There we go, Alembic Cache, Export Selection. We don't want to export everything. Bit heavy to work with all this geometry in Nuke, so let's just export the camera now, which we selected here, of course. So Alembic, export selection to Alembic. Let's pop its options open. Now we want to use the time slider, of course, and everything else should be on. I'm going to export into Maya 2014 standard Alembic cache and export selection. Now I have one under volume 4, so I'll call this one Camera Nuke and export selection, and that will just go ahead and export that camera to Nuke. And as you can see here, everything is moving around quite nicely. I could have hidden all this lot to export the camera and it would have been faster, but a couple of seconds. So I will see you back in the next part when we will take a look at swapping out this still frame for the animation. And it's actually not that difficult. All the color grading that we've done, the color correction, will be suitable for the still shot, for the animation as well. So basically we're just going to swap them out, create a 3D background, use some geometry in Nuke to put it on, some sort of cylinder, and that will depend on what sort of image you've got. I've got a panorama I took at the park that will probably do the job. If you've got a complete 360 panorama, then you'd need to use a sphere, obviously, but you know, it's not that difficult to put primitives into Nuke, which we'll discuss in the next part. So I hope you're finding this informative, and you know, if you've never worked with Nuke before, or you've never broken a render up into its particular passes and had a go at it, I hope you can see that this gives you a lot of flexibility to go from something that's rather oversaturated and fairly uninteresting in its way to something that's a little more atmospheric and a little more interesting. And you know, the kind of power that you've got here is much better than re-rendering 4,000 times in Maya to try and get just the right shade of grass or, you know, the right shade of tree. This is a bit more flexible. So thank you for watching, and I'll see you in the next part. Hi, welcome back. So the first thing I want to do is change us from this still shot to a animation. Now in order to do that, I'm going to change my project settings. So click anywhere in the node graph and hit S, and that will bring up the project settings. Now at the moment I'm using a full size format UHD 4K. What I actually want is a HD 720, because as I said, I didn't actually render the entire animation out in 4K. It would have taken a bit too long. Now, as you can see, when we set this to 720, that's actually the resolution we'll be using for the animation. So I'm going to go ahead and just save this comp as, and I'm going to call this one comp animation, just so I don't save over the old one. Okay. And now the main file that we have here, we have read in that images tutorials large and master file. Now I want to read in my animation, so I'm going to click here and go and find the files for my animation. Now, so this is my animation directory. It's just my project directory, images underscore animation v2. Yours will be in your images directory or wherever else you've chosen to save them out. And I'm going to take this master layer. Now I'm going to tick it off sequence, and as you can see, I've got a whole bunch of EXRs saved out here. So same as the individual file, each EXR contains the render pass information. So when I click this, I should flick off and get about the same comp as I had before. Now we've got a problem here because the let's see, this is the second depth, which we're not using right now, so let's just get it out of the way just so I remember what it is, and take that with you. And we've got this ambient occlusion here, which is being read in, let's see, and then multiplied down there before being passed over into the main node chain. So you can see we've got some occlusion happening up here. This is because obviously our scene is shrunk, so we need to reread in the ambient occlusion too. So I'll just go to the ambient occlusion and double click that one, and this is probably fog. So if I disable this grade, not the grade, let's just disable the merge to make sure our ambient occlusion is working. It appears to be. Let's go down to our fog and read in the fog. So this would be volume fog. There we go. And why has that? Why are we still getting this up here? Well, let's have a look. So we've read in the correct. That looks like some sort of fog to me. Let's just make sure I've got the right one here, and I think I've got the wrong one is the problem. Yes, it is. So final 1 to 125. There we go. And let me just double check. I got the wrong ambient occlusion too. Sorry. That's looking a bit more like it. Now you can see that we've recreated pretty much the same image, except for our background is now far too large. But we're going to do a 3D background. But for now, let's just, if you wanted to, just for preview purposes, you can of course move the transform of that, and then just come here and get that a little smaller. So shove that about where it was, and there we go. So now we've recreated basically our master image. So the color correct and everything that we had before is working quite nicely on this. Now some things will need to be tweaked, because when you've got larger resolution, especially with things like the fog, we might need to come in and add a little more. So if I come in and turn that up, so you might need to do a bit of recorrection. I mean, it depends on what you're looking for in your animation. So I kind of like it there this time. Let's clean the node graph so we get rid of all those widgets on the screen. And I'm kind of happy with this. So if I play it through now, we go back to the first frame. Nuke will then cache this out for me. Let's make sure, and things like depth might need to be tweaked. So let's hit D to turn the depth on. And I'm going to use a little bit less depth because this is kind of too much now. So I might go down to sort of 175. So you can't just swap directly from the animation to the still, especially if the still was 4K and the animation was 720, because you're going to get a few things that need tweaking. Some of the saturation that look good at 4K because of all the extra details could be, you know, a bit oversaturated for the animation, so you might have to go in, and I've got a path matte here, so if I trace it down, it's connected to this color correct, and I'm going to nip the saturation of the path because it's too saturated. When I can't see all the detail of it, it just looks a bit too bright. So I will go ahead and let this animation cache. If you just press play here, you can see this is going to go through frame at a time. Now if we had the depth turned off, then this would be very, very quick. But because we've got it turned on, it's going to calculate that depth for every frame and make us wait. So I'll be back in a minute. In fact, I'm just going to stop that because I've just noticed something here. Nasty grey line at the top, and I would like to know why. And I think that might be down to the transform here. Yeah. So what we've done is we just cropped off the top of our image there. So not quite big enough, maybe. Yeah, let's just scale that up a little bit. And obviously for your final animation you might want to take a bit more time in the placement, but as I said, we're going to be replacing this with the 3D option anyway. So just for this little preview, and I'll show you that the background not moving has a very weird effect on the animation. So I will be back in 2 seconds. Okay, so that did its thing. It took about 5 minutes, and I'll play it through for you. And we got one immediate problem with the grass, which I'm sure you'll see straight away. Other than that, it's looking very nice, I think. You can see the movement in the grass and the trees in the background. And the nice thing is, because our background is so far away and we've got movement there, you know, it's not really going to catch your eye that I've got one tree there that's not actually moving, the one that's fixed on the background. But if we look at this grass, this is not good at all. All these speckly lights coming on, and that's the cranked up direct glossiness. Now I cranked the direct glossiness on the still shot because I thought it looked nice. Unfortunately on the animation it's too heavy. So again I go back to talking about the fact that you can use a still shot to get the basic color right and the sense of atmosphere, and you know, but when it comes to the animation you will have to make a few small tweaks. So one of them for me would definitely be turn down the reflectivity of this grass. So if I go in and find the grass, so I've got grass A, grass B merged into one matte. I've also got grass A going out to its own matte. So let's find the direct gloss and see which one is which. So direct gloss, let me go in a bit quicker. And that one's coming in here. Let's see what this one is doing, and this one's giving us a very large white point, so it's probably that one, and it is indeed. So now I've taken off all that gloss. It's still got more glossiness than it did when we rendered it out of Maya, but now it's got all that gloss taken out. You might want to go in and change the diffuse a bit just to bring a bit more contrast into there. So again, I can just go up and find this mask where it's coming from, this one under diffuse. I can trace that back to the mask here, and I can come in and actually I want to just edit one portion of grass. So if I trace down from grass A matte, I come down, follow the chain. This is why it's nice not to have that giant spaghetti tangle in Nuke. I've been handed Nuke files from people in the past where you spend the first 4 hours just working out where everything is going, so try and keep a bit of neatness. Now we have a hue shift in here, and I'm just going to brighten it up a bit. Okay, but sorry about the video jump, folks, just had a slight machine freeze. So if we do this brightness a bit, you can see that I can introduce a bit of brightness within this hue shift, which is connected to our mask up here, which is connected to our grass mask. They seem to have got a bit muddled, but anyway, you know, you could drop a color correct in there somewhere as well if you wanted even more kind of contrast. Now we had to take out that whiteness from the gloss, but for me that's looking pretty good anyway. I may go in and drop in another color correct just to or use one of the existing ones if I've got one on that map. But really this is looking okay. So I'm going to just let that replay through from frame 1, and we'll see if we get that same problem down here on the grass. And again, these are things that you need to have the animation files generated to see, you know, is this too shiny? Does this Crawl is my final gather solution. Maybe not good enough quality, but we're looking pretty good. So I'll play this through and I'll be back in a minute, and we'll just check on that grass, because it might be that we can pump the gloss up a little bit, not quite as extreme as we had it for the still shot, but a little bit more than this. So I'll be back in 5 minutes when this has cached its way out. Okay, so I've cached out the first 45 frames or so. You don't need to cache everything out, and this will let me go a run through, and I'm not seeing any overly bright highlights on that grass. I'm not really seeing that crawl effect that we had before. It's got nice movement. In fact, the whole scene looks quite nice. But I reckon we could probably go back to the grade node that I've got on the direct gloss here, and to both types of grass, and just make it a wee bit more glossy. We'll start to get to about here maybe, and I think that will be fine. So again, you could cache out a few frames and shuffle backwards and forwards just to make sure. The nice thing is doing this in Nuke is much faster than doing it in Maya, and if we come in and actually just turn off this Z blur, this will cache out pretty darn fast. So you can see it's basically generating the depth of field through the Z blur that does it, and that looks pretty good to me. So I'm kind of okay with that. Now again, this is one of those processes that you can come back to, tweak it, preview it, tweak it, preview it. It's just much faster than re-rendering all the time. But this is looking pretty good. I kind of like the waviness of the grass, which obviously we generated with those animated paint effects, and I don't seem to be getting too much brightness, maybe a little bit, and one of the reasons I didn't grade this in front of you, or all of it at least, was because this can be a bit of a trial process, getting the look you want, matching exactly the color that you want with the tone that you want. It's just one of those things that you sit down for a couple of hours with maybe, and if you're not working from direct reference, then you're going to want to try a few ideas, some browner grass, greener grass, desaturated backgrounds and whatnot, the same way you would work in Photoshop really. So this is kind of looking good to me. The problem with it is that the camera moves, the house moves, the grass, the trees, everything else. The background stays exactly where it is, which is not great for us. It looks weird with the background being static. So in the previous part, we generated a Alembic cache file from within Maya, which just contained the camera. Now we could have done some geometry as well, and then used Nuke's relight to add more light into the scene. But really for us, we just need the simple camera movement, so we can tell Nuke that we want the background to follow the camera. So let's go and hit Tab and bring in a read geo node. Now I know we're not actually reading geometry, we're reading the Alembic cache file, but that's okay. We can just go up here and I'm going to open up that cache file. So here I am, and I'm in the cache Alembic directory. The cache by default for Alembic will go to your project directory, cache Alembic. So there's that camera Nuke that I saved out. I'm going to bring that in, and when I hit play, absolutely nothing will have happened. So if we go to the 3D view, okay, now again nothing's going to happen here. That's just going to whiz through there, not a sausage. So if we look up default camera, change that to camera 1, which will be the camera from the Alembic file. Then I come back here and hit play, and look at that. We are tracking movement. We have the camera movement inside Nuke. So now all we need to do is put a background in there, which we can't do without a piece of geometry. Let's go to geometry, and in my case cylinder is fine. Now that's come in a bit tiny, so let's scale this to maybe 150, 150, 150. We might have to have a look at that, and let me zoom out, and of course that might be a bit big, especially on the Y, so let's change that to 75 and make that a bit shorter. Okay, and I'm just holding Alt left mouse button and the scroll wheel to zoom in and out, and Alt right mouse button to kind of pan around. Now obviously as soon as I jump back a frame, we'll go back to camera 1. Let's put on this thing a texture. So let's grab out the image pipe from the cylinder geometry and drag it straight to our background image. Now you'll just see it's gone white, which means we're probably not inside the cylinder. So I'm going to do a zoom out here, and there is camera 1, which you can see is sitting outside the cylinder. So we can increase the size of the cylinder, or we can move it. You just grab the handle for it. So if I grab along the Z, I can move it along Z, Y, I can move it up. And we're going to have to get this into a bit more of a position in a second, but for right now we've at least got a camera inside our cylinder. So let's flip on to camera 1 again, and as you can see now I've got this cylinder inside here. Lovely. Now if I hit play, you'll see everything moves. The background is moving, the camera is moving, so we're kind of halfway home. Problem though, let's flick to 2D, and nothing has changed here, and I've got no way of telling this cylinder that it needs to go down here and be the actual background. So in order to do that we need to render it. So I'm going to use a scanline render. Okay, and now we just need to hook this up and replace this background. So let's just hook this scanline render object or scene up to the cylinder, and that will leave us with something that looks a little bit like this. So you can see it's probably a bit too big, so I've gone and connected the scanline render to the viewer. Now if I hit play, you'll see we're not really getting a lot of movement there. In fact, we're not getting any movement there. So let's go ahead and hook up the camera. That's a bit better. And now when I hit play, you'll see some movement. If you let it cache out, or if I let it cache out, you can see the movement happening. It's just we don't have much camera animation in our file. It's a very slow sweep over 125 frames. But as soon as that caches, you'll see that that is definitely tracking the same movement path that we have in Maya. Okay, so now we need to replace this with this. So I'm going to take this background and unhook it. I'm going to take the transform for the background and unhook it as well, because it's no longer necessary. In fact, I'll leave it connected to the background so we know that they're paired together. And then I'm just going to take this scanline render, unhook it from the viewer, and hook it into the node chain here. So instead of the background going into this color correct, I got this scanline render going into the color correct. Now I want to look at the whole thing minus the Z blur, and that should have done it for us. So if we look at just this, you can see there's the tip of the tree that we were seeing in the background, and if we look at the whole thing, there it is. Now you could obviously go up now into the 3D view and move this sphere about a bit. So if I just zoom out there, you could come in and move the sphere, change the size of it, the rotation and whatnot, to get the background exactly where you want it. But for me, it looks pretty good where it is. Because we got it hooked up to that scanline render, this will now be rendering it and feeding it in to our main pipe as the background image. So that's pretty cool, really. We just read in the alembic. This is really no longer necessary. We created a cylinder, and we hooked up a camera, the one from Maya, and the cylinder. We hooked up the cylinder to the object of the scanline renderer, and we hooked up the background image that we're using, the panorama in this case, to the image pipe of the cylinder. And when I redo this now, you should see that move. In fact, if I just keep that, you can see that the background is actually now moving with the camera. Okay, so I'll get one of these just previewed out so we can have a look, and I'll be back in a second. Okay, so that cached out, and at the moment we've got no blur on here, so the background is in too much a sharp focus, our now 3D background, but it'll give you an idea. So the whole backing plate is now moving along with the camera movement of the image. So we're just about done here, really. Now I'm going to show you how to write this out. It's just a write node in Nuke, so it's pretty simple. And I'm going to do one more pass of this thing. I'll just turn on the Z blur, because with the background this sharp, it's quite noticeable that the trees aren't moving. I mean, we get away with it, but with the blur, you know, you're not going to see much difference between the backing plate and what we have in the foreground. There's enough movement here to pretty much disguise the fact that we have a static image there. It's moving with the camera, which is nice. Okay, and as I say, you might want to go in and rotate that cylinder. So you can always move the cylinder, let's say. So if I come here and click on the cylinder, I can rotate it, let's say 50, and you'll see that, whoops, along the wrong axis, of course. So let's go 50 this way. You'll see the backing plate move. So depending on where you want that bright spot of highlight there, let's try 150, too bright, 200, no, 100. There we go, so 75 maybe there, and I got that bright patch over there. So you can always, you know, adjust this, and that will continue to move with the camera, of course. So if I hit play now, you'll see that it's still moving, albeit quite slowly. And if you want to get rid of its X, Y, and Z coordinates, you can just come up here and clean up the node graph. And I kind of liking this more. My light is coming from sort of over this way, so this is quite nice. I've got a couple of big trees in the background here, maybe too big. I was originally looking to take a backing plate that wasn't quite as many trees in the background as the one I got, but I live in the middle of a city centre and I haven't had time to go out to a field to take probably a better backing plate for this would be without the trees, but needs must. So let's come in, and I might turn the volume fog down a little bit. So I'm just going to use the merge node for that, so just a little bit less fog. I'm going to turn this on, D. I'm going to go back to that cylinder and cylinder, and I'm just going to change the rotate here to 0. I actually, just by the luck of the draw, got it in a good position that I liked on the first attempt, which absolutely never happens until now. So, you know, bear in mind that if that doesn't happen with the backing plate you're using, which it probably won't, because I think this is the first time I've ever just dropped in a backing plate and gone, I like it. So without having to move the cylinder too much or, you know, rotate it to get the backing picture in the place I like, this just kind of happened to work, which is nice. So the Z blur is on. Let's just double check, but I can see it's very blurry down here. So we have our Z blur on, and I'm kind of liking the blurriness of the background to the foreground. We've got a little blur going on right at the front of the camera here. Got the house in focus, so we're all good. Okay, we could also try swapping out our anti-alias to depth, just to see if we get a better result from that. But I think, you know, like I said before, for animation work, you're better off sticking with a true Z depth 99% of the time. You know, you might get that one occasional surprise. And I think this is pretty much good to go. So I will cache this out one last time and then show you how to write it out to a frame sequence, and we are pretty much done here. Okay, so I've recached this out so we can see it play through, and I would say if this looks a little jumpy to you, it's because I'm recording this video at 15 frames a second and I'm playing it back at 24, so it might be a bit rough, it might jump about a bit, but it's smooth in real life, if you like. So I'm going to stick a video of just this on YouTube so you can see how smooth the whole thing is. So if you are seeing that jump, then it's just because of the mismatch of frame rates between the tutorial recording and the playback in Nuke. Now I could slow Nuke down here to 15 frames a second as well, but probably the best thing to do is to just check out on YouTube or play it through yourself. I'm going to leave all of the files necessary within the tutorial download. So, just load it up in Nuke and give it a play blast yourself. You can then obviously change colors and have a play around with the color correction. But I'm happy with this. Now we've got that blur in the background and everything seems to be working just fine. You could look at maybe tweaking the color correction to a bit more of your liking, and I'm not entirely sure that we don't have a little bit too much gloss still on this grass, but small details. The sky is moving nicely, the background play is fine, it's matching up, the foreground is fine, and for the limited amount of time we've had for this composite, we got the nice shadows moving about from the moving trees, which really help to sell the shot. For the limited amount of time we've had for the composite, I didn't want to get too complicated, really, especially as we're kind of hoping that people that haven't done a lot of compositing will be watching this. So, this should get you started in the right direction. You should be able to then take all your render passes and layers from Maya, go into Nuke, put an animated background on there, and Nuke will match your camera movement. So even if you've got like a huge 360, you can still use the same technique where you put an image on a background cylinder or a sphere, depending on how you took your image. So really, I am quite happy with this. All that remains is that we write out the files. So now we've got all this in Nuke, we need to get it out of Nuke, and this is actually a fairly simple proposition. We can go down to the end of the node chain, hit tab, use a right node, okay, intersperse that into the end, so it should be the very last thing in. Now you can put it before the viewer, so you can still see everything, but it should be the last thing in the chain. This will then write out everything coming down to this point, so it will write out all of this information into individual files. So if we look here, under the right node, you've got render. If we hit render, you'll see frames. You can switch this to global in this case because we are from frame 1 to 125, and this will render out 125 frames of this animation with the background and everything else, all the color correction. Now let's just go and give it a file name. So in our case we'll call it test, and I'm going to go file type, let's just do a JPEG for now. So you got the JPEG options, and the same thing if you put this to PNG, you'd get data type 8-bit, 24-bit for PNG, EXR, TIFF. So you've got your kind of standard files, anything you want really. Now if I hit render, you'll see this has come up frame 1 to 25. This will probably be set on input by default, which will only render one frame. So change it to global. And we want to take off continue on error because this is going to error now, and you'll see it cannot be executed for multiple frames. Now the reason for this is our test name here, or test file name, so you could call this whatever you want, it doesn't matter, it will still error. The thing is that Nuke doesn't know how to put the frame padding in for this, so it doesn't know whether to call this test 1 followed by test 2, test 3 for the individual images, or test 01 or test 0001 depending on how many you're going to render out. So to do this we can use the hash. So this would now render out as test 01, test 02. As we have over 100 frames though, that's not going to work. So we'll put another one in, and this will now render out as test 001, 002, and so on and so forth. So same as the frame padding in Maya. Once we've done that, we can hit render and hit go, and it won't do anything. We need to now, because we've got the frame padding in there, tell it what it is. It's a little awkward, the right node when you first start, but if you turn off that continue on error, you'll soon see the error messages, and it's pretty intuitive. So let's hit go, and now it's calculating, now it's rendering out my frames. So then I'll have 125 TIFF frames that I can then use, maybe Adobe Media Encoder or anything else I want really to put those back together into an AVI, an MP4, whatever format I'm using. There is a short Free Friday tutorial on SimplyMaya. You can find it on the forum or our YouTube channel called How to Render a Batch Movie, that will show you how to save this lot out as an AVI once you've got the individual frames. But really from Nuke what you want to get out is those individual frames, and then you would use something else to put them together. So either VDub, which is free if you do a search for virtual dub on Google, you'll find a program that can combine single frames into MPEG 4 or AVI or pretty much any format you want. Or if you use something like Adobe Media Encoder, that will do single frames. So that's about it really. I will actually cancel that because I don't need these as TIFFs at the moment. Just wanted to show you that right node. So you will then have your files written out and everything will be good to go. So I really hope you've got something out of this series of tutorials if you've been with me through the first one. If you have any questions, feel free to contact me, David, at SimplyMaya, or you can get me on the simplymaya.com/forum. Bunch of nice people in there as well that I'm sure would be happy to help if you have any questions. So if you go ahead and you've come this far and you've got your own animation, your own house, or whatever you've decided to do, post it up on the SimplyMaya forum as well. I'd love to see it. And thank you very much for joining me throughout this series. And as I say, any questions, feel free to get in touch. Thanks for watching.